So, advanced PostgreSQL. The goal of this unit is to learn about database performance and techniques for efficiency, accessing data, and maintaining optimal performance. These skills would help keep your query times low even as your database scales. After this unit, you'll be able to use different database data access patterns, efficiently access data, understand data performance optimization practices, and use software to track database performance. And we will put all of this knowledge into practice with an upcoming portfolio project. Sure. Let's move on. Day 4 of 5. Holy crap, did the week go by fast. It's like Thursday already. Alright, so in this lesson, we'll work to build out a database schema that will store information for a conference. Our database will be designed to accept input from a variety of applications, user-filled forms, and other sources. We'd also like to put data validation in place to protect our database from receiving unexpected, improperly formatted, or invalid data. Luckily for us, PostgreSQL offers methods to safeguard a database and maintain database integrity or data integrity. One of these methods is called constraints. Constraints are rules defined as part of the data model to control what values are allowed in specific columns and tables. Specifically, constraints reject inserts or updates containing values that shouldn't be inserted into the database table, which can help with preserving data integrity and quality. And it will raise an error when they're violated, which can help with debugging applications that write to the database. All right, let's work towards designing a data model we might use to schedule our conference. To start, we have the following tables with no constraints. So we have talks and we have speakers. In the next few exercises, we'll discuss how a thoughtful implementation of the following rules and constraints could improve our data model. All right, we're somewhat familiar with them. Write two statements that select the first 10 rows of talks and speakers. What is the title of the talk with ID 3? Selects the first 10 rows of talks and speakers. All right, so select everything from talks and limit to 10. Do the same speakers and also limit to n. All right. Could have done it in one query, but it's what they're asking us. Do two queries. All right, so what is the title of the talk with ID 3? Deploying database to the cloud. Speaker ID 1, which would be S. Scott Bolton of Miller Analytics Limited. He's a data analyst, has 8 years of experience. Very experienced guy, it seems. Okay. PostgreSQL offers several ways a database engineer can ensure that correct data is entered into a column or table. One of the most basic methods is built into the create table syntax that you've probably already seen before. In a create table statement, we specify the data type for each column of a table. In doing so, we're telling PostgreSQL which types of values can be inserted into each column in a table. You can refer to the complete list of available data types in PostgreSQL documentation. Alright, so we have booleans, we're familiar with that, varchars, dates, integers, numeric, decimal with total digits A, and digits after the decimal point B. Ah, interesting. So numeric is decimal with total digits A. So you can even limit the amount of digits it has and digits after the decimal point. Okay. And we also have time, which is time of day with no time zone. Alright, so to create a table that stores information about volunteers for the conference, we could write the following. So ID, name, hours, available, phone number, and email. Sure, we could do that. In the statement above, we ensure that our volunteers table will have integer values for data in columns ID and hours available, and text values data. Oh, text values data in columns name, phone number, and email. However, data types don't prevent all unexpected data from being inserted into the table. For example, we've defined phone number as varchar and might expect a 10-digit phone number formatted as XXXXXXXXXXXXXXXX. An incomplete value formatted like XXXXXXXXXXX will be accepted because it's under 12 characters. Also, a value like plus XXXXXXXXX will cause PostgreSQL to raise an error because it's longer than 12 characters, even though it is a valid entry. Another potential issue caused by relying only on PostgreSQL data types stems from the fact that PostgreSQL will try to interpret incoming data as the data type the column has been defined as. This process, called typecasting, can have mixed results. If one tries to insert 1.5 into our table's hours available column, PostgreSQL will cast this value to integer, round the data, and insert it into the table as 2. Oh, okay. If one tries to insert 1.5 into the email column, we'll insert this into the database by casting 1.5 to a string. Okay. So let's add a table to our database that will keep track of attendees. So we want to create morning yawns. Just gotta embrace it. Embrace the yawns and roll on. So create a table attendees. And we need ID, which is integer. I have to get used to capitalizing SQL keywords because it's much more readable that way. So we do integer, then we have name, which is varchar. We also have total tickets reserved, which is an integer. We also have standard tickets reserved, also an integer. And we have VIP tickets reserved. Typing is hard today. Integer. Okay, that should be okay. Yep. Write a statement that inserts a row with the following values into attendees. This insert should not succeed. Inspect the error message the database returns. All right, so insert into attendees values 1 John Smith 2.5 1 and 1. Um, oh, 2.5 in 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 these things. All right, so invalid input syntax for integer 2.5. All right. Remember, we can't always rely on PostgreSQL to interpret our input exactly as we'd like. In this case, PostgreSQL isn't clever enough to convert a decimal in quotes to an integer. Alter your query insert to into total tickets reserved. Oh, just do 2. Yep, that works. Okay. Nullability constraints. In some cases, we might enter data into our database without including a value for every column in each row. Yeah, and for example, this could happen when aggregating data from multiple sources that don't have the same input columns. Missing null values in certain columns might make our data much less useful. For example, if we're loading data into a data table designed to keep a record of talks, we may want to require fields like title, session time slot, and speaker ID to be filled for an entry to be valid. After all, what's a talk without a speaker? Suppose we insert a row that doesn't contain all desired fields into our current talks table. We can do this with the statement below. Yes. We can query this table to see how this row looks when inserted into PostgreSQL when there are no constraints in place. So title and session time slot and speaker ID will be null. As expected, we can see that there are null values in the title, session time slot, and speaker ID columns. With PostgreSQL, we can choose to reject inserts and updates that don't include data for specific columns by adding a not null constraint on those columns. With this constraint in place, PostgreSQL will reject the insert statement that contains incomplete data. PostgreSQL will raise an error alerting us that these rows violate the constraint and that our insert or update couldn't be completed. Let's consider how we might implement this constraint on the talks table. If we know which columns cannot be null before creating our table, we can add a not null constraint following the data type in the table's create table statement. Yeah, we already kind of done this. So, all right, so suppose we are creating a speakers table from scratch. All right, sure. Create table speakers. And table with not null constraint on ID, email, and name. Okay, so ID, integer, not null. Email or char. Also not null. And name var char not null. And everything else can be null. So organization var char title var char the pirate's life for me. And years in roll integer. Yep, should be correct. Yes. Try inserting the following row to confirm our new constraint is working. Examine the error message. Can you identify which of the not null constraints is violated in this row? Well, I can already see that it's the name one, but sure. Insert into ID, email, organization, title, years in row, values 1. Let's just copy. Oh, just copy this. And then ABC Corp Copper Corp. How come I can't write Corp? All right. CTO and 6. Oh no, syntax error. Wait, what? Syntax error? Is it semicolon? No. Oh. Speakers. There we go. Null value in column name violates the not null constraint. Yep. For this to be valid insert, we must insert a value into each of our not null columns. Change the insert statement from the previous exercise to insert a value, a Wilson, into name. So name and a dot Wilson. Wilson! Wilson, where's my Vicodin, Wilson? I think his name was Wilson. Heh. I did the thing. I did the thing! What's your problem? He didn't like that I didn't do a dot here. My god. Codecademy, you're so pedantic. Improving tables with constraints. Sometimes we've planned out a data model and inserted data before realizing that our model could benefit from the addition of a constraint. In PostgreSQL, we can use alter table statements to add or remove constraints from existing tables. In fact, all of the constraints we'll cover throughout this lesson can be added to an existing table by writing an alter table statement. Let's imagine we've already populated our talks table with some data, but we haven't included any constraints. Suppose that the column session time slot contains no null values, and the column title contains about 50% null values. Since we've already created and inserted data into our table, we probably don't want to recreate and repopulate it from scratch. Instead, we can add a not null constraint to a column using alter table statement. Let's add a not null constraint on a session time slot with the following statement. Set. Okay, so alter column, alter table, alter column, and set not null. Okay. If we later decide we no longer need this constraint, we can drop a not null constraint from an existing table with the following statement. So again, alter table, alter column, and drop not null. If we'd like to add a not null constraint to the title column, we can attempt to do so using the same syntax we used to add a constraint on session time slot. Yes? However, PostgreSQL will reject the addition of the constraint and raise the following error because null values are already present. I was about to ask, like, if there are already null values in the column, probably won't be able to do that. If the table we're attempting to add a constraint on doesn't meet the constraint, we can backfill the table so that it does adhere to the constraint. Backfilling is a term occasionally used in database engineering to refer to the process of adding or updating past values. In this case, we can fill our table's columns null values with a placeholder value using the query below. Yeah, so TBD where title is null. Okay. With the table updated, So that there are no longer any nulls in the title, we can now apply the not null constraint. Yeah, okay. So write an alter table statement that adds a not null constraint on the name column of our speakers table. Sure. Alter table adder. Alter table speakers alter column name and set not null. All right, so suppose we'd like to implement a not null constraint on organization, but the column already contains null values. Write an update statement that fills the null values in organization with a placeholder value. So update speakers set organization to TBD, and where I guess organization equals or is null, right? Yeah. Write an alter table statement that adds not null constraint on organization. Alter table organization no, wait, speakers alter column organization set not null. Yep. Easy peasy. Easy peasy. Introduction to check constraints. Ooh, these will be interesting. In some situations, we might want to establish specific rules to determine what makes a row valid. For example, in our talks table, we might want to ensure that the estimated length column is A, an integer, B, not null, and C, positive. The first two rules can be implemented with a data type and not null constraint respectively, but the third will require additional logic to enforce. We can use check statements to implement more precise constraints on our table. A check constraint can be written into a create table statement or added to an existing table with alter table. To use a check constraint, Thor is having a nice dream. His tail was wagging there for a moment. Alright, so to use a check constraint, we list check following the data type in a create table statement and write the conditions we'd like to test for inside. We'd like to test for inside the parentheses. Okay, the condition tested for inside of parentheses of a check statement must be an SQL statement that can be validated as either true or false. These statements are similar to the statements you may be familiar with in where clauses when filtering rows from a table. Let's add a check statement to ensure our talks table has a positive value for estimated length for each row. Sure. In some situations, you may want to apply multiple constraints on a single column. In this case, we'd like to also add a not null constraint on estimated length. We can add additional constraint on a column with multiple alter table statements. Alternatively, if we know the constraints we'd like to include as we're creating a table, we can list following the column name and data type in create table statement. To implement the constraints we've covered in this lesson, I'm running out of air. You could write estimated length, integer, not null check, blah, 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 into the create table statement for talks. Returning to our speakers table, write an alter table statement that adds a check condition in years in roll. This constraint should make sure that the years in roll is less than 100. Wow. Codecademy being ageist. Alter table speakers. Speakers. Alter. Wait. Is it update? Oh, we add a check. Add check. And estimated length is less than 100. No? Oh, years in roll. Never mind. Years in roll. There we go. Check constraints continued. Inside a check statement, we can use a wide array of SQL syntax to create our conditions. For example, within our check constraint, we can make comparisons between columns within a table, use logical operators like and or, use other SQL operators you may be familiar with, such as in and like. As a general rule, any logic that you might use in a where statement to filter individual roles from an existing table can be applied within a check, including logic that involves multiple columns or conditions. Suppose we'd like to add a check that all entries in talks have an estimated length between 0 and 120 minutes. We could apply such a check with the following. We can also apply constraints that apply to multiple columns. For example, suppose we want to enforce the following. An estimated length less than 120 minutes and year of the talk should be 2020. We can extract this value from session time slot. We could do this by adding separate checks on each of the columns. Alternatively, we could add a single check constraint that checks both conditions as shown below. So estimated length is less and date part returns a portion of the date as an integer. Year session time slot equals 2020. Interesting. All right, we'll jump into the exercises, but I'm gonna take like a 1 minute break to hit the bathroom because my bladder is exploding. Thor can't decide which room he wants to be in, so he's just chilling in the hallway and in this room at the same time. Alright, so using one check statement, write an alter table statement that adds a constraint on speaker to ensure that values for years in role are between 0 and 100. All right, so alter table speakers, add a check that checks that years in role are less than 0 and years in role are greater. Oh, actually, greater than 0 and less than 100. Yep, that should work. Okay, so recall our attendees table from the earlier in this lesson. What is that sentence? So far, the table had the following create table statement. So using one check statement, write an alter table statement that adds a constraint on attendees to ensure that standard tickets reserved plus VIP tickets reserved is equal to total tickets reserved. Ooh, that's an interesting one. Alter table attendees nuts. Boom. Add check. And we're basically doing this. I'm just gonna copy and paste this. Just to not waste time retyping stuff. Boom, it works. It just works. That's how we like to do it. Alright, unique constraints. When designing a PostgreSQL data model, it's a good practice to structure tables such that rows are uniquely identifiable by some combination of attribute. Structuring your tables this way leads to a few benefits. The structure of your data model and the contents of individual tables are more easily interpreted. Queries to access information from the table can be simpler. For example, if we'd like to query our attendees table to find out how many tickets an attendee has reserved, having a unique identifier for each attendee allows us to get a result without any intermediate aggregation. Identifying and implementing a primary key is easier on tables with unique constraints already in place. Okay. So in our attendees table, suppose that we'd like to make sure that no two people submit the same email address when they register. To do so, we could apply a unique constraint on email. To implement this constraint, we could include it in our alter table statement. To identify values in a single column as unique, we specify unique following the column name and data type definitions. In this case, we'd write email varchar unique in our create table statement. Yeah. Alternatively, we can add the constraint to an existing table using the following: alter table attendees, add unique email. Returning to our talks table, suppose we'd like to use the combination of speaker ID and session time slot to ensure that a speaker is never booked for multiple talks at the same time. We can do this in the create table statement by specifying the columns that need to be jointly unique, in parentheses, on its own line following the column names and data type definitions. Statement by specifying the columns that need to be jointly unique in parentheses on its own line following the column names and data type definitions. Okay. In this case, we'd add a unique speaker on its own line in the create table statement. Okay, that's interesting. Just as with single column unique constraints, we can also add. Am I having a stroke here? We can also add the constraint with an alter table statement. All right, that must be a typo, or I'm having a stroke. Okay, so returning to our speakers table, write an alter table statement that includes a new constraint on email so it can be used to uniquely identify rows of the table. All right, alter table, speakers, add unique to email. Done. Okay. So edit the create table statement below that defines a new table called registrations. Include a multi-column unique constraint that ensures attendees are registered for only one talk at a time. Sure. Create table. ID integer. Not null. Attendee. ID integer. Not null. Session time slot timestamp not null, null actually, and talk ID integer not null. Right, and then finally we just do unique and we do attendee ID and session time slot. Right? Right? Think so. Yeah. Okay. Introduction to primary keys. Well, it's a bit of a delayed introduction to primary keys since we've been using them for ages now. God damn it. Okay, having unique constraints is useful, but an important part of building a relational data model requires defining relationships between tables. Primary keys are essential to defining these relationships. A primary key is a column or a set of columns that uniquely identifies a row within a database table. A table can only have one primary key, and in order to be selected as a primary key, a column should uniquely identify that row in the table and contain no null values. Implementing a primary key constraint is similar to simultaneously enforcing a unique and not null constraint on a column. Although unique not null and primary key constraints function very similarly, tables are limited to one primary key, but not limited in how many columns can have both unique and not null constraints. Roger that. So, in addition to defining relationships between tables, primary keys also improve your data model in several other ways. Many joins will use the primary key from one table to join data with another table. Primary keys can also improve query performance, and primary keys help to enforce data integrity within a table that by ensuring that rows can be uniquely identified. Alright, recall that attendees table has a column named ID that uniquely identifies attendees. We have also already restricted the name and email columns to be not null. Now let's add ID as our table's primary key. So with alter table, we can do just ID, add primary key ID. And while creating the table, we just write primary key. Even with the primary key, there is still a good reason to use a combination of unique and non-null constraints to enforce data integrity on other columns. In this case, the combination of unique and non-null constraint on email can be used to validate that all attendees have a value for email. and each unique email can only be matched to one attendee. Now that you're familiar with how primary keys work, for the remainder of the lesson, you may assume that all tables in our data model have a primary key on their ID column. All right. So let's implement a primary key on our speaker table. Write an alter table statement that adds an ID on the primary key. Alter tables. Speakers. Add primary key onto ID. Great. Now that we've implemented a primary key on ID, we can confirm that it upholds both unique and not null constraints. Write the insert statement that writes the following information into a single row of the speakers table. Sure. Insert into speakers set. Wait, no, not set. We do email, name, organization, title, and years in role. Values. Let me just copy all of this quickly. Jones Saunders. Jones solders. He likes to solder. In his ABC Tech. Senior Data Scientist. God damn, that's a fancy title. Not only is he a scientist, he's a data scientist. And not only is he a data scientist, but he's a senior data scientist. Crap. So that should be fine. Let's see. Null value in column ID violates not null constraint. So the previous exercise showed us that our primary key upholds the not null constraint. Let's confirm that the ID also upholds a unique constraint. Insert the following row with ID. So we just change. We just add ID here, and we add a 1 here. Boom. Yep. Duplicate key value violates unique constraint speakers key. Joe Ozfek, thank you for the follow. Welcome to the stream. How's your day, Joe? Or morning, maybe. Or evening. Or afternoon. Or post-lunch. No, this is the same thing. What else is there? Night? Could be night. How's your after midnight? That's a thing too, I think. Alright, introduction to foreign keys. We've also learned about those before, but, you know. Let's use some of what we've learned so far about primary keys to improve registrations. Recall the registrations table that we previously created had an ID primary key column and had fields attendee ID, session time slot, jointly unique, so that no attendee may register for 2 talks with the same time slot. Roger that. In this model, the talks in registrations are meant to reference the talks described in talks. Yep, that's not confusing at all. Because of this, we'd probably want to ensure that any talk ID entered into the registrations references an ID that already appears in talks. The talks in registrations are meant to reference the talks described in talks. Shouldn't be talk ID. Yeah. Because of this, we'd probably want to ensure that any talk ID entered into registrations, references an ID that already appears. Oh, I forgot what we're reading about. It's foreign keys. Of course we want to do that. Okay, so when discussing relationships between tables, you may see the term parent table and child table to describe two tables that are related. More specifically, values inserted into child table must be validated by data that's already present in a parent table. Makes sense. Formally, this property that ensures data can be validated by referencing another table in the data model is called referential integrity. Makes sense. Referential integrity can be enforced by adding a foreign key on the child table that references the primary key of the parent table. By adding a foreign key on the child table that references the primary key of the parent table. Okay, so if the parent table doesn't contain the data a user is attempting to insert, PostgreSQL will reject the insert or update and throw an error. And throw a tantrum, more like. Let's work through the example described above to improve registrations. In our example, above registrations is a child table of talks, because entries in registrations must reference the primary key from talks. Okay, so post talks also has a column named ID as a primary key. Now, we can update our registrations table with a foreign key using the following statement. I'm reading stuff and like, I don't know, 50% only is like registering in my brain. Alter table registrations, add foreign key talk ID, references talks ID. Okay, we kind of already did this when creating tables. Yeah, references talks ID. Suppose now we want to enter a registration for talk ID 100, which does not yet exist in the talks table. Trying to insert a registration for this talk yields an error because there is not a corresponding entry in the talks to reference yet. The error below us lets us know the constraint is working and provides a helpful error message that indicates we need to add an entry to talks before this insert will succeed. Okay, let's do it. We can use foreign keys in a few other places throughout our data model. Let's ensure that talks can't be inserted into the talks table without the talks speaker already existing in the speaker table. Write an alter table statement that ensures talk column speaker ID references speakers column ID. Okay, so alter table speakers. What was the add foreign key? Okay, add foreign key. Speakers ID references speakers ID. Like this? No. Oh, we're supposed to add this into parentheses. No? What? Add foreign key references speakers. A space here? No. What? Sure, the talks column. Speaker ID references speakers column ID. What's your problem? What's your problem? Oh, talks. Wait a sec. Oh, talks table. Right. Eh. Speaker ID. Okay, let's test out this foreign key constraint. Try to insert the following row into talks and inspect the error message. Does it look as expected? We will see. Insert into talks. Let's do ID, title, speaker ID, estimated length, and session, time slot, values, 21, data warehousing best practices. Speaker ID 101, 30 minutes, and the time slot as such. Yeah, I think so. Okay, so insert or update on table talks violates foreign key constraint. Talks speaker ID F key. Okay. Cascading changes. Oh, take a sip of water. In the previous lesson, we've discussed how foreign keys enforce referential integrity by preventing updates or deletes on the parent table until the child table is updated first. An engineer can specify the strategy Postgres will use to maintain referential integrity as they define their foreign key constraint. By default, a foreign key constraint will prevent an engineer from deleting or updating a row of a parent table that is referenced by some child table. This behavior is sometimes explicitly specified in a create table statement using references talks ID on delete restrict or on delete or on update restrict. However, another strategy you may consider is adding a cascade clause. Rather than preventing changes, cascade clause on update cascade and on delete cascade causes the updates or deletes to automatically be applied to any child tables. For example, suppose we'd like to set up our database to automatically unregister attendees from a talk that's been canceled. To do this, we could apply onDelete cascade to our foreign key constraint. So alter table, add foreign key, references talks ID onDelete cascade. Okay. When we try to delete a value from talks, we also notice that our registrations from talk ID 1 are removed as well. This preserves referential integrity by removing any row associated with this talk. To demonstrate, let's first return the rows in registration for talk 1. Sure. Great. We observe 7 registrations for talk ID 1 in registrations. Yes. Now let's use the following code to delete the talk ID with ID 1. Delete from talks where ID equals 1. Because we specified onDelete cascade on our foreign table or on our foreign key, the delete statement ran successfully, even though there's still rows in registration that referenced talk ID 1. Let's check to see what effect this statement had on registrations. Everything's gone! As expected, records that correspond to talk ID 1 have been removed. In effect, onDelete cascade runs the required deletes on the child table behind the scenes and allows the user to simply run a single command to update a data model. Okay, so let's implement a rule that says if a speaker is removed, their talks are removed as well. Let's fill the alter table below with an on-delete cascade clause that implements this rule. So alter table talks, add foreign key talks ID probably, or speaker ID, references speakers ID. There's probably speakers ID here as well. And on delete, we cascade. Correct? Not correct. References speakers. Yes. Oh, syntax error. What? Near speakers ID. Oh, I keep forgetting we have to add these into parentheses. Still not happy? Probably speaker ID. Yep. Alright, let's check this constraint is working. Write a delete statement on speakers that will remove the talks in the speaker with ID 2 was scheduled to present. Inspect the schema for the talks table before and after this delete. Okay, so have to practice deleting. Delete from talks. Oh, it's pretty simple. Delete from talks where ID is equal to 2, right? Yes. So before we have 20 rows of data, and now we have 19. What's your problem? Oh, from speakers. Whoops. Okay, now we have 9. Wait, doesn't make sense. Because we have speakers, right? And we delete one speaker, and the same speaker could be giving multiple talks. Wait, unless I forgot. Oh, never mind. Okay, yeah. We had 10 speakers and 20 talks. And now we delete one speaker. We're left with 9 speakers and 18 talks. Yeah, that makes sense. The table switched positions for some reason. I was a little bit confused. Okay, so we're done with constraints. Good job. You made it to the end of your lesson in PostgreSQL contains blah 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 blah. So any new information here? Constraints or rules in database engineering, blah 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 blah. So we have constraint talks and Codecademy forums. As one last exercise, we filled the schema you've been working on with some simple data for the following table. We've included no constraints on this table. Feel free to play around with the data, add constraints, additional sample data, and think of how you might model the relationships between these tables. No, thank you. Because we'll be doing this later on exercises and whatnot, so. Quiz time. Assume we filled the runners table with several hundred entries, including some with missing values for club. So we're backfilling here, I think. Fill the following code so that the not null constraint can be added to the club column without causing an error. Alright, so set club unattached, where club is null. Yep. What is the difference between a primary key constraint and a unique and not null constraints combined? So a table can have multiple primary key. Nope, a table can have multiple unique columns, but only one primary key. Well, yes. Unique not null columns cannot contain null values. Primary key columns can. No, they cannot. Unique not null constraints can be defined on multiple columns. A primary key must only be one column. That's also incorrect. That's the correct answer. Consider the create table statements for artists and songs. Fill in the code to add a constraint that ensures that all values inserted into artist's ID in songs refer to an ID of an artist present in the artists. Holy crap, that's a mouthful. And all right, so we're altering. Fill in the code constraint ensures that all values inserted into artist ID in songs. So we're altering songs and we're adding a foreign key artist ID that references artist's ID. Yes? Yes. Suppose we'd like to store a school's course catalog in PostgreSQL. Which set of statements could we use to ensure that each row in courses has a unique, not non-null value for call code? So add unique call code and then set it to not null. Yeah. Fill in the code that would add a constraint on songs that ensures that each row has a non-null value for artist's ID. So alter table songs, alter column artist ID and set it to not null. Yeah. All right, using the results table defined below. Fill in the alter table statement to add a constraint that ensures place has a greater value than 0. So alter table place, add a check, and let's do... Wait, that ensures place has a greater value. Oh, place, this should be results table. Yeah. Columns in PostgreSQL database table can have multiple constraints. Fill in the code to create a table named states with a unique and not null constraint included on the abbreviation column. Place the unique constraint first. So unique and not null. Nope, unique I said and not null. Yeah. I think Thor got spooked by someone milling about in the hallway outside. What is it, boy? What is it? Timmy's down the well? Oh, no. Alright, which of the following insert statements would PostgreSQL reject based on the definition of courses table below? So we have courses as ID integer and call code as varchar. So that's 5. That should be fine. That is 6. So this one. Yeah. Consider the create tables. What is going on? I'm hearing weird noises. All right, so consider the create stable statement. Create stable. Let's create some stables, guys. Create table statements for artists and songs. To ensure referential integrity between the two, we'd like to add a constraint that ensures that when an artist is removed from artists, their songs are removed from songs as well. So we need to do alter table songs Add a foreign key artist ID that references artist's ID, and we're doing on delete cascade. Yes, yes. Okay, so using the results table defined below, fill in the code for the alter table statement that adds a constraint to ensure that each row in the results has a unique value in the place column. So we're just doing add unique and place. Alter table statement that adds a constraint to ensure that each row in results has a unique value in the place column. Yeah. Okay, we're done. Let's continue learning with a project, which we will do after a break. And we are back. What happened to my scenes as well? They got a little messed up. Okay, there we go. Alright, so we have a project. Building an inventory database with PostgreSQL. In this project, you'll build out a database schema that could be used to organize an inventory of mechanical parts. This schema will keep track of all the parts, their manufacturer, category, location, in storeroom, available inventory, and other relevant information. A database like this might be updated and queried by an inventory management application that accepts input from many users who might not be familiar with the database structure. As a result, we should make sure that there are sufficient data quality checks to ensure that only valid data can be entered into the database. Alright. So the next few instructions will guide you through adding constraints to the parts table. So before making any changes, write a query to inspect the first 10 rows of parts. Sure. Let's take a look. Alright, so we have ID, description, code, manufacturer, and we have 3 more tables such as location, manufacturers, and reorder options. Damn, 265 rows. Okay. So the parts table is the central table in our database. It stores all the information. Wait, is it? It doesn't store anything about reorder options. What is a reorder option? Okay. Let's make sure that we have some basic checks in place to ensure data integrity. Alter the code column so that each value inserted into this field is unique and not empty. Alright. So alter table parts. Add. Wait. Is it add? Add. Huh. Alright, let's quickly take a look at our cheat sheet. Got a text message. Ooh. Something got arrived. Oh, my Amazon thing. Should be here between 2 and 4 o'clock. Alright. Perfect time, to be honest. Won't have to sit on pins and needles while streaming to be able to play around with my new mic arm. Let's take a look at the path. And advanced PostgreSQL. And let's take a look at the cheat sheet. Right, so atomicity. The hell? Acid, acid, acid. What is with this acid? I didn't do anything with acid yet. We have roles, granting, revoking. These are permissions. Data types. Where's my alter thingy? Multiple constraints. Foreign key constraints, cascade and restrict. Ugh. Okay, it's not here. Alright, let's just duplicate this and go back. Like one lesson, I think. Back. Oh, I can't go back. Back. Maybe I can? Yes, I can. No. Wait. Okay, there we go. Back. Add foreign key. Okay, so foreign key we add. Foreign keys, this is primary keys. Unique. Oh, he's just add unique. Okay, so add unique. Actually, no, there was another way to do it. Where was it? Check constraints. No. Alter. Yeah, alter column. Okay. Alter column. And we do code. We set unique and not null. There we go. Huh? Alter column, code, unique. What? Oh, set. Not null. Can we do it like this? No. Okay, well, let's do set not null and then set. Sure, let's add another variant of this. Add unique and code. So that should be correct. Yep. Alright, so the parts table is missing values in the description column. Alter the table so that all rows have a value for description. As an extra exercise, think about how you might alter the table if you wanted to fill in missing description fields with different values for each part. So we have the description. Let's take a look at the table again. Parts, and let's limit that to 10. So, description. Well, we could have like alter table, Atler, alter table, parts, wait, is it alter? Update. update parts where description is null. And we set, wait, it's set should be first. Set description to be equal, let's say, code. Can we do this? Code plus 1, like so. Wait, no. Think about how you might alter the table if you wanted to fill in missing description fields with different values for each part. So this will just fill in the descriptions with the code, with part code. Alright, let's take a look if this works. No. Operator does not exist. Character varying plus unknown. No operator matches the given name and argument type. Okay. How do we fill in? What if we just leave the code? Okay, no errors. Let's take a look at the table again. Like, neighbors doing construction again. Wait, it didn't... Didn't do anything. Huh. Update parts. Set description to be equal to the code where description is null. Huh. How come it didn't do anything? What if we just do this? Still nothing. What? Am I misspelling description? No. Update parts, set description to be equal to code. Where description is null. Our code is unique. Wait a second, we kind of... How come it allowed us to set code to not null when there are null values in there? Unless these are no longer null. Okay, let's comment this out. Let's try to do like this. No, still nothing. Huh. Okay, this is bizarre. Okay, so let's do select from parts where description is null. What? So none of them are null? Should be equal? No. Wait, no, this is fine. The code stuff is fine because that's code and we're working with description, of course. But why isn't it setting? Okay, what if we just delete this? Okay, so we changed everything to code. But if we do where description is null, should it be like when? No. Makes no sense. So are none of the values in here actually null? Is that the problem here? Manufacturers. Where is it? Parts. CVS. Parts. Okay, let's say 3. Color LED. Wait, no. Here. Wait, what? ID. ID 3. Yeah, here. So it is... It is null. What in the hell is going on? Okay, now change the ones that are not null. Wait. The part with the code V1031 has a null value. ID 3. What? So it's not null? Okay, this makes no sense. I'm trying to see how I could implement some kind of string formatting. Is that a thing that happens here? That could happen here? Code. One? No. Okay, but that is weird. So these empty values are apparently not null. They're just like left blank or something. So central stores information about it. Make sure that we have some basic checks. Alter the code column, that's fine. Parts table is missing values in the description column. Alter the table so that all rows have a value for description. As an extra exercise, think about. Okay, well, we can just do the description as... Wait, let's ask Mr. ChatGPT in SQL, is there some kind of string formatting when updating table values? String formatting functions, concatenate. Replace, substring. Okay, we can use concatenate. Set description, concatenate, and we'll do code. Oh, we do column name, oh no, additional text. Concatenate column name and additional text. Okay, so this is our column name, and our additional text is missing description. I don't know. Let's see what happens. Nothing? Ah, there we go. Okay, it works. Let's do M. Boom. Okay, well, we technically did it, but we didn't do it the way we're supposed to do it because the empty description cells are not actually blank, so we can't really select them. Wait, besides blank, no, besides null, what other types are there in SQL when there is no value in a cell? Empty string, default value, 0 or blank, special marker values, -1 or NA, sentinel values, missing or undefined. These values are distinct from regular data and are chosen specifically to signify. Okay, placeholder values. All right, so there also could be an empty string. 0. Or a blank space. Might represent the absence of a meaningful value. How would I go about targeting a blank space. Like. Ah. Okay, let's try that. So, from parts. Alright, for now let's hide this. And let's do where description, like this. No. All right. What about an empty string? No. Ah, there we go. Okay. So just a space, it's not actually null. Okay, so we can uncomment that. We can do that, and we can do where description is equal to a space. So now, if we do this, where did it go? Do 20. What? It's just gone. They're just gone. Wait, parts we have... Oh, they're probably at the bottom, aren't they? Because updated values for some reason go to the bottom, yeah. Okay, but they're still in the table. So, okay, we did that. Even though it took us a little while, but it is done. Let's do limit to 10. Okay. To test that you've successfully backfilled parts, add a constraint on parts that ensures that all the values in description are filled and non-empty. So we will just alter the table parts and add unique to are filled and not empty. No. We will alter column description and set not null. There we go. Or what are you doing there? Huh? What are you doing there? I don't want you to wander off on your own. Doing naughty things that you're not supposed to do. Okay, so we have successfully backfilled parts, descriptions. Okay, so test the constraint by trying to insert a row into parts with the following information. Sure. Insert into parts. We will do ID, and we will do code, and we will do manufacturer ID. Values. Ah! Values. Do 54. The code will do V1009, obviously in pause things, and then we'll do 9. Boom. Null value in column description violates not null constraint. So it works. Okay. So we can delete that. In our database schema, we have a table called reorder options. This table keeps track of the parts, quantities, and prices available for their manufacturers. Now, let's implement a check that ensures that price USD and quantity are both not null. Can you think of some other constraints we might want to add to this table? Alright, let's first add these ones. Are not null. Can we add... Can we alter... reorder options, multiple columns at once? Alter column. So we'll do price USD and quantity set not null. Can we do this? No. Fine. Huh? Reorder options. Am I misspelling it? No, I'm not. Syntax error at or near reorder options. Alter column. Price USD. Set not null. What? Where's the syntax error? Yeah, just did the same thing here. Oh, alter table. Gosh, Paul, why you gotta be so stupid? And let's try quantity again. Quantity. Nope, doesn't work. What if we add it into parentheses? Price USD and quantity. Nope, doesn't work. Okay. Well, we're improving here, right? How to alter, wait, no. How to add not null constraint on multiple columns at once. Oh, just like that? Oh. Ow. Price USD. And we can copy and paste this here, and we can do quantity. So this should work. Alter table, reorder options, alter column, quantity. There should be a comma, yeah. Okay, we did it. Okay, what other... can you think of some other constraints we might want to add to this table? Well, Where is it? Here. ID, part ID. I don't know. Let's implement a check to ensure that price USD and quantity are both positive. Oh, that makes sense. Can you think of how to enforce these rules as a single constraint and as two separate constraints? Well, yes, maybe. Alter table, reorder options, add check. And we can do price USD is greater than 0 and wait. Well, okay. And quantity is greater than 0. That should work, right? Let's try it. Insert into reorder options, set price USD. Oh no. We're inserting, we're not updating. Where's my reorder options? ID, let's do, I don't know, 500. Part ID, let's do 200. Part ID. Sure, 200. Price USD, let's do minus 200 and quantity minus 1. New row for relation. Violates check constraint. Reorder options check. Yep, it works. And if we just do one of them, that should throw the same error. Yeah. And if we do just this, then we're fine. All right, it works. Let's assume our storeroom mostly tracks parts with a price per unit between 2 cents and $25. Add a constraint to reorder options that limits price per unit to within that range. Assume that price per unit for a given ordering option is the price divided by the quantity. Okay. Alter table reorder options. Add a check. So, that limits price per unit. We have quantity and price USD. To within that range. Assume that price per unit for a given ordering option is the price divided by the quantity. So, price USD divided by quantity cannot be... Oh, must be either greater than 0.02 and the same thing, except less than 2500. Right? Okay, so if we do insert into reorder options. And we will insert, well, let's take a look. So ID, let's say 500. Part ID, sure, like 7,000, whatever. So price per unit, what if we do 25 and we do 1? So that should, no, doesn't work. Is less or equal to, or equal to. There, so that should work. Yeah, so that was inserted, I think, 266. There should be 265 of them. Yep. Okay, so that was inserted. Now, what if we do 2? It was still inserted. What are you eating? Are you eating random string off the floor? No, that's illegal, dog. Illegal. 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 Okay, so that still got inserted. How come? Our price divided by quantity. Oh, because 25 divided by 2 is not 25. Okay, what if we do 100? That's still equal to 25. What if we do 1,000? Okay, now it's scaring me. 25 divided by 1,000. Excuse me? Okay. 999 divided by 10. That's 99. So that should be correct. I'm bad at math. Yes. Welcome to the stream, everyone. What in the 1,000? Excuse me? Am I just that bad at math? 99 divided by 1,000. How did I get what? All I have to do is just do 2. There we go. Okay. It works. It works. I'm bad at math. Okay, so add a constraint to ensure that we don't have pricing information on parts that aren't already tracked in our database schema. From a relationship between parts and reorder options that ensures all parts in reorder options refer to parts tracked in parts. Alright, so we have to add a foreign key to we have parts. Wait, part ID. Oh, it's already here. Okay, so we just have to alter the column. Okay, so alter table parts. No. Alter table reorder options. And wait, how do we We're supposed to add a foreign key. Oh, it's just add foreign key. Okay. Alter table, add foreign. key, which will be part ID. And this, we just do references, right? Yeah. And this references parts ID, I think. No. What? Parts does have ID. So we're altering the table that does not have or does it have? Wait. So talks has speaker ID, and we're altering talks. Oh, okay. Add a foreign key on speaker ID, which references speakers.id. So here we should do alter parts and part ID, which references reorder. Wait, what? No, that doesn't make sense. Because reorder options is the one that has the part ID. So we're adding foreign key on the part ID, which references reorder parts, reorder options, ID. Yeah, okay. I think I messed it up here previously. I think I wrote like reorder parts or something, or just parts ID. Okay, never mind. It works, I think. Or does it? What helps is translate the following logically into human language. Modify the reorder options table, sure, by adding a foreign key constraint on the part ID column. This constraint references the ID column in the reorder options table, establishing a relationship where the part ID column values must exist as ID values in the reorder options table. Okay, so to simplify this further, simplify. Make sure that the values in the part ID column of the reorder options table correspond to existing values in the ID column of the same table. Make sure that the values in part ID column of the reorder options table correspond to existing values in the ID column of the same table? No, we don't need to do it on the same table. We need to do it on parts. form a relationship between parts and reorder options that ensure that all parts in reorder options refer to parts tracked in parts. There is no unique constraint matching given keys for referenced table parts. So is it just that parts is not a primary key? All right, let's check something before we do things. What was it? Select all from information schema, I think. Dot. No, not triggers. Keys. No. SQL information schema. Columns, tables. Columns? Oh my god, so many. PG catalog. There. We have... Oh wait, no. Column name, table position, catalog, data type. No, we want to check... we want to check... keys. From information schema, referential constraints, order position, column name, table schema, important schema, cardinal position, column name, table schema, constraint name schema. No. Table constraints. Could it be that? Like, we have column names, we have ordinal position. We don't have enough space in this thing. We have UDT name, catalog. Where are the... Wait, let's take a look. Generation expression, blah. Is self-referencing, CDT identifier, scope catalog, UDT schema. No, that's not what we need, I think. Pretty sure there was a way to check. What kind of keys were there? Is it in data type? PG no tree, PG no tree. How are there so many tables? Or so much information about so few tables? Wait, what is this? User mapping options, foreign server catalog, foreign tables schema. Okay, well. Wait, where did my thing go? Where did my output go? Okay, we can actually go back. No, go home. Now it's just to remember which one it was in. I think it was in database basics. Working with your first types of dates. Or was it here? Take a look at the cheat sheet. No. Types of databases. Working with your first database. Using Postgres on your own computer. Okay. F it. F it. Okay. Add a foreign key. Okay, there is no unique constraint. Matching given keys for referenced table parts. No. There's no really correct answer here. Okay, we have add foreign key. Okay, how would we do it if we were creating a table? Right? So if we had like create table reorder options, right? And we just were adding the part ID, we would be doing integer and also references part ID, parts ID. Right, which is essentially the same. Like on our table, reorder options, we're altering this table. We're adding a foreign key part ID. On part ID. Oh, come on, Codecademy. Which references parts ID. All right, let's consult Dr. ChatGPT. I am trying to add a foreign key. Getting the following error. Somehow, consulting ChatGPT with SQL seems a bit more preferential. The error message indicates that the column or columns referenced in the foreign key constraint on the reorder table do not have a unique constraint in the referenced table parts. You need to ensure that the column or columns being referenced have a unique constraint in the parts table. How can it not? Okay, fine. We'll do alter table parts, add primary key onto ID. That work? I think it does. Have to go back to the thing that we were looking at beforehand. It was advanced PostgreSQL. Yeah, here. And we need, where was the primary keys? There. Yeah, that's how you add. Okay, so now it worked magically, I guess. So they did it on purpose. They didn't add a primary key on ID just to mess with me. God. Rawr. Okay. The location table information. The location table stores information, actually, about the location of a part for all the parts available in the store. Let's add a constraint that ensures that each value in quantity is greater than 0. Sure. Alter table. Locations, right? Yeah, locations. And we just do add a check. Check, please, that QTI is greater than 0. Okay. Let's ensure that locations records only one row for each combination of location and part. This should make it easier to access information about a location or part from the table. For example, our database should display part 1, location 1B, count 5, instead of. So we have to add a unique constraint to to part ID and location. I think so. Yeah. Okay. Alter table. Locations. Add unique. And we do part ID and location. All right. Nope, not this one. This one. Let's ensure that for a part to be stored in locations, it must already be registered in parts. Write a constraint that forms the relationship between these two tables and ensures only valid parts are entered into locations. All right, so this is analogous to this one. So we can kind of just post off of that. Right, so our locations has part ID. We already added parts. We already added a primary key on the ID of parts. So all we really need to do is just add antler table. Yes, alter table locations. Add foreign key to wait a sec. Locations, yeah. Part ID and which references references, thank you, which references parts ID. Relation part does not exist. Oh, parts. Ah! Insert or update on table location. Violates foreign key constraint. Locations part. Ah. So that means that we have invalid parts entered into locations. Is that the case? Our locations is quite massive. Okay, let's think about this. We're trying to insert or update on table locations. Violates part ID 54 is not present in table parts. Ah, okay, well, let's comment this out. Let's take a look at our locations. So select all from locations where where part ID equals 54. So we have 2 of them. And if we do the same with parts. Oh. Do the same with parts. We don't get anything back. So we have to probably just drop these 2 rows. Now, the question is... delete. Delete from where... Ah, okay. So we can do... Delete from, right? Yeah, delete from locations where part ID equals 54. And if we query the select again, select all from locations where part ID is equal to 54, we should come up empty. Yep. And so let's delete that. Let's move this over here. And now if we uncomment and run this, it should run successfully. Yes. All right. And finally, let's ensure that all parts in parts have a valid manufacturer. Write a constraint that forms a relationship between parts and manufacturers that ensures that all parts have a valid manufacturer. All right, so we have a manufacturers. So we will do the opposite now, where we will do alter table parts, and we will add a foreign key, which will be manufacturer ID, which references manufacturer's ID. But we're probably going to get an error. No, we didn't. Okay, that worked. All right, so let's test the most recent constraint we've added. Assume that PIP Industrial and NCC Manufacturing merge and become PIP NCC Industrial. Create a new manufacturer in the manufacturers with an ID of 11. Okay, so insert into manufacturers. We will do... No, we won't do anything. Let's do values. And ID 11. And also PIP NCC Industrial. That should work, if I'm not mistaken. Now let's take a look at manufacturers. Yep, we got it. Okay. And update the old manufacturer's part. Update the old manufacturer's parts in part to reference the new company you've just added to manufacturers. Oh. Okay, so update table parts, set manufacturer ID to 11, where manufacturer ID is equal to, what was the old one? It was NCC and PIP. So 1 or manufacturer ID equals to 2. So currently we don't have any here, but we could where is it? This one. Parts where manufacturer ID is equal to 1 or manufacturer ID is equal to 2 or 11. So if we comment this out for a second and we run this query, we will get all the parts with old manufacturers. Now, if we run this query, we get the same syntax error at or near table. Update. Is it just update? Yeah, it's just update. No, didn't work. What? Oh, because we're queuing it before. Let's take a look. Where is it? There. And now it all changed to 11. The same parts, yeah. 22, 33, 015, MQ7, yep. Update the old manufacturer parts reference company you just add to manufacturers. Done. We're done. Done with the project. Cool. That was pretty fun. Alright, so we will tackle permissions next. Alright, let's get back into it. Last push until lunch. Let's see. So, we're doing permissions now. When you create a new PostgreSQL database server, there will be a single database and a single user, both usually named Postgres, available. In PostgreSQL, you can run the following command to check the name of the current user. Okay. The Postgres user, or any initial user, has the ability to create new databases, tables, users, etc. In PostgreSQL, the term for a user with these types of permissions is superuser. A superuser bypasses all permission checks that other users face before being allowed to perform an action. In these Codecademy lessons, this user is most often named CC user. Superuser privileges are not restricted to a single user. In fact, the superuser designation can be passed along to any number of other users in the database. However, the superuser designation is a dangerous privilege and should be used sparingly. In computing, there is a rule called the principle of least privilege that suggests all applications and users should have only the minimum permissions required for their function. Okay. So to adhere to this principle in PostgreSQL, you want to ensure that most users' privileges are restricted. Superusers are not performing routine database tasks. Okay. And specialized roles are created with only the permissions they require. Okay. Okay, so let's just do select current user. Alright, CC user. Fair enough. Let's move on. Investigating superuser permissions. As a superuser, you may want to check the permissions of users in your database to ensure that they have access to only what they need. 1 second, guys. My package is here. All right, we're back. Sorry about that. I'm expecting a lot of packages today. Where's my phone? Gotta have that on view so that nothing slips my notice. Okay. Let's move on. So, the following tables and columns are particularly useful for understanding the state of any user's permissions. So, PG catalog, PG roles, a listing of all users in the database, and a description of what special permissions the users have. Alright, and then we have information schema table privileges, description of the permissions a user grantee has on a table. This table can be used to answer questions about who can select, insert, update, etc. values on a table. Okay, so you don't need all the columns in this table to understand what permissions apply to a user on a table. To illustrate how to interpret this table, let's look at the example below. Alright, so select grantor, grantee, table schema, table name, privilege type from information schema table privileges, where grantee equals users B. Okay. Select update. Each row of this response corresponds to a single permission. The name of the privilegee, or privilege is shown in the privilege type column. Okay, the grantor column tells us the name of the role that originally granted the privilege. Okay, so user B granted a select privilege to user A in the finance table, or finance table schema in the finance table. Okay. So alternatively, as a super user, you can use a set role to mimic the permissions of other users. For example, if a super user runs set role, test role, and then attempts to perform an action that role couldn't, they'd receive the following message indicating that they don't have permission. Ah, so you can like test roles that way. Okay, this behavior is identical to connecting to the database with that role from the start. As a super user, you can run set role super user role to regain all super user privileges. Okay, so several users have been created in the database. Write a query to PG catalog PG roles that returns the names of all the roles in the database. Okay, so select, I guess, just role name from information schema dot table. No, it's not table privileges, is it? Or is it? Oh, let's take a look. Privileges. No. Wait. Oh. PG catalog, PG roles. PG catalog. PG roles. Is that it? I think so. Okay, so that gives us users, or like roles. The names of all the roles in the database. Analyst, Signal Backend, PG Stat Scan Tables, PG Read All Stats, PG Read All Settings, and PG Monitor. Okay, let's test the permissions of the user named Analyst. Set your current session to the role Analyst. Okay, so we just do that with set role to Analyst. Yes. Write a query that returns grantee table name and privilege type from table information from table privileges where grantee is analyst. This will show all permissions that analyst has on tables in this database. Sure. Where grantee equals analyst. Okay, so the analyst is only able to select stuff in the event log. Can analyst select from event log? Yes, he can. Still using the role analyst, run the following statement. What does the database return? Okay. So select everything from event log where ID equals 1. Select everything from event log where ID equals 1. Yes, I ran this. Near ID. Oh. Bahre. Alright, so we got this test event. What if we run everything? There's just one thing there. Okay. Okay. There's a lot to remember. Information schema table privileges. And then PG catalog, PG roles. Alright. Creating and modifying database roles. As a super user, one of the permissions you have is the ability to create new roles. In PostgreSQL, roles can either be login roles or group roles. Login roles are used for most routine database activity. Group roles are typically do not have the ability to log in themselves, but can hold other roles as members and allow access to certain shared permissions. Okay. The create role statement takes a series of arguments that modify the specific parameters around the newly created user's permissions. You can create a new login role using create role name with list of permissions. Okay, for example, to create a role with the most basic privileges, you might use the following: role sample user, no super user login. What is this? No super user. Is this role able to log in? In-role list of existing roles that a role. What list of existing roles that a role will be added to as a new member? This sentence is not making sense to me for some reason. List of existing roles that a role will be added to as a new member. Okay, let's move on. Let's take a look at the full list. Okay, we have to specify like super user, no super user, create DB, no create DB, create role, no create role, inherit, no inherit, login, no login, replication, no replication, bypass roles, no bypass roles, connection limit, encrypted password, valid until, in role, in group, role, admin user, sys ID. Okay. So, just like tables or schemas, roles can be altered. As a super user, you can use the same syntax as create role to alter an existing role. The following statement alters a role Miriam and gives them the ability to create new databases with create DB. So, alter role Miriam with create DB. Okay, so sometimes you may see create user on older versions of PostgreSQL. Create user is equivalent to create role. Except create user assumes with login, while create role does not. Okay, it is better to practice the more up-to-date syntax, create role, when using more recent PostgreSQL version. Okay, so let's create a role analyst. So create role, analyst with has the ability to log in and no super user privileges. So no super user and login. Yeah. Create a new role named Analyst Management. This role should have the ability to log in and create new roles, but should not be super user. Okay, create role. Role analyst MGMT and no super user login, and also create DB. Correct? Not correct. Oh, create role, not create DB. Alter the role you just created to have the ability to create databases. Okay, alter role analyst MGMT with create DB. Use the SQL below to confirm that Analyst Management has the elevated permissions we expect. If successful, we should see a new database user named Wilson in the result of this query. Okay, so set role analyst list MGMT, create role Wilson with login, and select all from pg catalog.pg roles Ordered. Order by role name. Okay, what have we got here? Well, we have Wilson, C user, analyst management, and analyst. Ah. Okay. Pretty straightforward stuff. Modifying permissions on existing schemas and... gotta get comfy. And tables. In addition to being used to manage who can log in and create new databases and roles, roles are also used to manage what schemas and tables users can see and modify. Every table or schema in a PostgreSQL database has an owner that can set the permissions on their table. As a super user or table or schema owner, you may use grant and revoke statements to modify these permissions at the schema and table level. To use a schema, a role must have a permission called usage. A role must have a permission called usage. Without usage, a role cannot access tables within that schema. Okay, so other schema level permissions include create and drop, which allow the grantee the ability to create or remove tables in that schema respectively. To interact with the table, a role must have usage on the table's schema. Additionally, a table owner must also grant select, update, delete, insert, etc. on a specific table to define how that role can interact with the table. Okay, so let's examine what this looks like in practice. As the owner of the schema finance, perhaps you'd like to grant the ability to select and update a table named finance.revenue to a user named analyst. You could accomplish this with the following. First, by granting usage on the schema. Okay, so grant usage, create on schema, finance to analyst. Okay, then by granting the table specific permissions. Grant select update on finance.revenue to analyst. Notice that when granting permissions, the specific permissions can be listed successfully as in statements above. Okay, any grant statement can be reversed using quite similar syntax. First, replacing grant with revoke, and to from. For example, to revoke the ability to update given... For example, to revoke the ability to update given above, the owner of the table could use the following statement. Revoke update on finance.revenue from analyst. Okay. Let's take a look. So, grant usage. Create on schema. Marketing to analyst. Yes. And so write an SQL statement that grants select, insert, and delete on the table marketing prospect to analyst. So grant select, update. No. Select, insert, and delete on marketing dot prospects to analyst. I think that's correct. Yes. Now we have to revoke, delete. Revoke, delete from, no, on marketing dot prospects from analyst. All right, run the SQL below that sets your role into analyst and tries to delete from the marketing prospects. So set role analyst and delete from marketing prospects where ID is equal to 2. Permission denied for relation prospects. Okay. I mean, it works. Modifying default permissions. To make managing permissions easier, PostgreSQL introduced a feature called default permissions. With default permissions, a super user can set permissions to be updated automatically when new objects are created in a schema. With default permissions, a super user can set permissions to be updated automatically when new objects are created in a schema. What does that mean? New objects are created in a schema. So when I create a new table, permissions will be updated? Okay, let's work through an example. Perhaps we want to allow a role named analyst to be able to select on all tables in a schema. In a schema finance, regardless if they're the owner or not. Default permissions only apply to objects created after the defaults are set. So we still need to ensure the following grant statements have given the role access to the schema and the tables that already exist in the schema. All right, so we're giving him the usage first to the finance schema, and then we're giving him access to select on all tables in the schema. Okay, so without default privileges, anytime another user creates a table, that user or a super user would need to execute grant select on table to analyst before analyst could interact with the table. With default permissions, this process becomes much smoother. The following statement would allow analysts to select on all newly created tables in finance immediately after another user has created them. So, alter default privileges in schema finance and grant select on tables to analyst. Okay. So, does that still require usage? Default permissions can be used to set permissions at the database level as well. For example, Replacing in schema finance with in database name in the query above would apply default permissions across the whole database. In general, any permissions that could otherwise be set with a grant statement can be applied to newly created objects with altered default privileges. Okay. However, there is not an equivalent to alter default privileges statement in all SQL databases. If you're working on an older PostgreSQL system or with another database server, you may still need to set permissions manually. Okay. So let's do the exercise. Grant a role named writer the ability to select, delete, update, and insert on a table named Census Economic Survey. You may assume that the role already has usage on the schema. So we do grant, select, delete, update, not wipe date, update, insert, on, like I'm trying not to look at the examples, on census dot economic survey for writer? No. On to writer? Yeah, okay. This schema will soon be populated with many tables containing data from other census surveys. Modify the default privileges so that select, delete, and update and insert are granted to the writer on newly created tables in the census schema. So we do grant default. Or is it like update? No, it's alter default. Okay, alter default privileges in schema census, grant, select, delete, update, oh my god, update and insert on tables to analyst, no, to writer. Is that correct? Yeah. Use the SQL given below to create a new table in the census schema. If we've set default permissions properly, then permissions we just defined will automatically apply to this table as well. Okay, so create table census dot housing survey. We want area ID int primary key and median rent int. Okay, so now let's confirm that altering the default privileges has had the desired effect. Now that Census Housing Survey has just been created, run the query below to confirm that all privileges appear in the information schema table privileges. Alright, select, let's get some finger practice. Grantee, table, schema, table name, privilege type, from information schema dot table privileges where table schema is equal to census and grantee is equal to writer. My God. Okay, so yeah, we have two tables, economic survey and housing survey, and the writer has all the permissions specified. Yep. Okay. Oh, my goodness. It's becoming hard to think. Holy crap, how much more stuff do we have? Quite a bit. Why are these not cleared? Did I not finish you? I feel like I did. Creating and modifying. Modifying permissions on existing schema tables. That's done. Modifying default permissions. That's also done. Groups and inheritance. Oh, there we go. Okay. Earlier in this lesson, we mentioned the fact that all roles in PostgreSQL are either login or group roles. In PostgreSQL, any role can be assigned to be a member of another role. For example, Alice, Bob, and Charlie can each be login roles, and they can also all be members of a group called employees. As members of a group role, these accounts can inherit certain permissions from employees. If a super user granted select on a table to employees, Alice, Bob, and Charlie would be able to select on this table because they are members of employees. This is a useful feature for maintaining databases with many users, but only a few types of users. You could have a database with hundreds of users, but if their permissions are managed through just a few group roles, the job of maintaining permissions is far simpler. Okay, so however, members in a group don't necessarily all share the exact same permissions. Consider the example below. Alice and Bob are both members of a group employees. This grants them all permissions granted to employees. Alice, marketing, and Bob, marketing and sales, are also both members of additional group roles. Because they are members of these group roles, they also have all the permissions granted by those roles. Finally, they also have permissions granted only to their login role. Okay, holy crap. Okay, so you can see a larger version of that second image here. There are some gotchas with the role inheritance that you should be aware of. For security reasons, PostgreSQL disallows the inheritance of certain powerful permissions, such as login, superuser, createDB, and createRole. This prevents a developer from accidentally granting high-level permissions to a wide group of users. Okay. So there are several ways to create a new group role. Using createRole and with role option, when creating a role, this automatically adds the listed names to the role. So create role marketing with no login role with no login. And and then you list the names, I guess. Using create role and grant statement, this grants all the permissions of the newly created role to the listed names. So create role finance with no login, and then grant finance to Charlie, Billy, Bob, and everyone else. Okay, you can also add users to groups on creation by specifying in-role along with the create role statement. Create role Fran with login, in-role employees and managers. This is getting confusing as hell. Okay, let's create a group role called PGDBA with super user, create DB, and no login permissions. For the moment, do not include any roles within the group role. Okay, so create role PGDB A with super user, create DB, and no login. Huh? Yes, I did that. Oh, syntax error. Oh, we don't need the commas here. Okay, create a user named David with login. David should be added as a member of two already existing groups, PGDBA and employees. So... Nope, sneezing coming. Oh. Okay, so create role David with login, enroll PGDBA, and employees. Is that correct? Yes. Using the PostgreSQL internal tables, confirm that David doesn't have super user permissions. Write a select statement that returns role name and role super user from... Okay, select role name, role super. From PG catalog .pg roles where role name equals David. Okay, how come he doesn't have the super user though? Because we put him in the PGDBA role or group, which does give super user. Huh. Okay, let's confirm that David has inherited permissions from employees. Employees has access to select from the table named company start dates. Do you expect David to have access to this table? So if he didn't inherit any roles from PGDBA, he probably shouldn't have inherited anything from employees. So set role David and select all from cc user dot company start dates. Oh. What? So he does have access? Okay, I need a better explanation. Using the following code, explain why role David inherits employee. It's employee, right? Yeah. Employees group permissions, but not ones from PGDBA, I think. View provided creates two roles. Okay, PGDBA and David. Then attempts to set the current role to David and execute the query to table. Wait. Okay, it might be confusing things. It is a role with super user privileges, the ability to create databases and without login permissions. David is a role with login permissions that is a member of both PGA and employees' roles. The role David is assigned to inherit permissions from both PGA and employees' roles. This means David will inherit permissions granted to both PGA and employees. The query select role name role superior blah 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 checks the properties of the role David. It should return David and the value of role super user, which indicates whether the role is a super user or not. Such as the current session to the blah 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 blah. David inherits permissions both from PGA and employee's role because it's explicitly set up to do so. However, PGA does not inherently inherit any permissions from employees because there's no explicit statement indicating such inheritance. Thus, David will inherit permissions granted to both PGA, but PGA will only have permissions explicitly granted to it. Okay, but when running the select statement, it select statement on PG roles, it states that David does not have super user. Given that David does not have super user privilege, it means he cannot inherit super user attributes or permissions from roles. What are you talking about? It means it cannot inherit super user attributes or permissions from roles, it is a... Right! Right, of course. Because the whole purpose of... Where was it? I think it was in the previous thing. That you cannot inherit certain roles. A couple of which are... super user, create DB, and something else. Login, I think. Okay, I understand now. We can move on. Jesus Christ. This thing is so confusing. Okay, we have column level security. Sometimes we'll want more fine-grained permissions than at a table or schema level. For example, consider the table projects with the format below. If we'd like a role to be able to see all columns from this table except for budget target. Oh my god. If we'd like a role to be able to see all columns from this table except for budget target, we might consider splitting projects into multiple tables. One table project budgets that contains project code and budget targets, and another project's name that includes project code, project name, project status. From there, we could grant permissions on project names and restrict access to project budgets. Holy crap. Lots of reading today. Jesus. Luckily, we don't have to go through this process. PostgreSQL offers the ability to write grant statements that specify specific columns for a set of permissions to apply. Ability to write grant statements that specify specific columns for a set of permissions to apply to. Okay, consider the following example. So, grant select, and we're setting columns on projects to employees. Okay, so with these permissions in place, when a member of employee attempts to select on projects, the server checks if they have access to all the requested columns. For example, if employee executes the following, an error would be returned, permission denied for table projects. Select everything from projects, limit 1. Okay, but then you create a situation where anyone trying to select from the table... Oh, another sneezing coming. Nope, false alert. But then you're creating a situation where anyone working with this table in the employees, after this takes effect, they have to sort of guess which column was limited. Furthermore, not only they have to guess, but they can also incorrectly assume that they don't have permission for the entire table entirely. No? Am I being silly? Okay, so this is because the start includes budget target, a column that employees don't have access to. When the query is changed to the following, no error is thrown because the query doesn't request any restricted columns. Alright. Write a grant statement that allows a role named manager to select on the table projects. You can assume manager already has usage on the schema, but no permissions defined on projects yet. Okay, so we can grant select. grant select on table projects to manager. Oh, good. I thought I was remembering that wrong. Write a statement that will allow the role manager to update on project name and project status, but not on the other columns available. Okay, so grant update on project name and project status. On projects to manager. Let's confirm that the update to permission was effective. Write a query that returns all rows from information schema column privileges where manager is the grantee. Okay, so select all rows from information schema dot column privileges where grantee equals manager. All right, so he has column names. We have budget target, only has select. Code name status target. So name status code target, and he only has update privileges on status and name. Okay. All right, so then we have role level security. In the previous exercise, oh my god. Well, that was a nice stretch. In the previous exercise, we discussed how column level security can be used to manage permissions on specific columns in a table. PostgreSQL has a feature called row level security that allows developers to define permissions on individual rows. Row level permissions act as an additional layer of security beyond schema and table level permissions to access or modify information from a table with RLS. Crap. 1 second there. To access or modify information from a table with RLS, a row-specific condition must be met. For example, let's say we wanted to create a system where all salespeople in group role sales can view their contracts in a table called contracts. Without RLS, any user can select contracts belonging to another salesperson. There are a few steps required to enable RLS. First, we create a policy using a create policy statement. The syntax can be a bit tricky. Yeah, no shit. No Schmidt. No Schmidt. So create RLS policy on a table account and specifies the permissions type the policy applies to. So create policy EMP RLS policy. I guess just the name, just we give to it on accounts for select. Okay, and we give it to sales using salesperson equals current user. Specifies the role sales this policy applies to. Okay. And specifies the condition to check before permitting a user to carry out an action. In this example, the policy is that the current user must equal the value in that row's salesperson's column. The result of this statement is now we have an inactive policy named EMPS. An inactive one? EMP RLS policy. Next, we need to enable RLS on the table or policy refers to. So we alter the table accounts and enable row level security. With RLS enabled, if Bob were to select everything from accounts, they'd only see the rows where they're listed as the salesperson. Okay, so create a policy on accounts for a group role sales that enforces the current user must match the salesperson before being able to delete rows. All right, so we create policy. Let's say delete rows policy. Why did I do rel? Delete rows policy. So we do on accounts or delete to sales using salesperson must be equal to current user. Okay, and then we enable it. So alter table accounts, enable row level security. Set the role of the current session to Alice. Okay, so set role Alice. And as Alice, run the SQL given below. Which rows do you think this query will affect? Does the table contain any rows with a contract AMT under 10,000? I don't even know. All right, let's do delete from accounts where contract where contract AMT is greater than 10,000, and then we select everything from accounts. Contract AMT again, where Alright, let's actually take a look at stuff before and after deletion. So, oh, it deleted everything for Alice, where the contract amount is less than 6,000. Yeah, that's exactly what we wanted. All right, wrap up. Congratulations, this concludes the lesson on database security with roles. In this section, we've covered quite a few concepts related to database security. super user permissions, group and login roles, Postgres internal permission tables, schema and date and table level security, row and column level security. Now we have quiz, yes, which we will do after lunch. This will give us the opportunity for the knowledge to sink in a little bit and not be as fresh, where we can easily answer these questions without having to think. But in the meantime, have a good lunch, guys. I'm gonna take out the dog and eat something myself and also stretch my legs. So I will be back in 30 minutes. In the meantime, I'm leaving you with machine suppress. All right, and we're back with a quiz. Thor, no, you cannot go there. That is forbidden territory for you during streaming, because I cannot keep my eye on you. Yes, that's correct, Mr. Thor. You are cute, but you're not gain access to forbidden territory cute. Yes. Go to your bed and play with your toys there while I'm doing work. Ah! Yes. Yes. Okay. Enough. So we have a quiz. He's sniffing the package. No. Illegal. 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 Bop. Bop. Gonna get bopped on your forehead if you go there. He's just sitting here begging for pets. Okay, so select the statement below that grant the ability to select on product books to David. Assume David does not have usage on products. So first we have to grant him usage on schema products, and then we grant him select on products books. Yep. Which of the following will create a login role named Alice with no super user privileges but with the ability to create other roles? This one? Because we don't necessarily have to specify the super user privileges. Create a login role named Alice with no super user privileges, but with the ability to create roles. It's this one. Yep. Fill in the code below to finish the query that would allow a user to return all of the privileges a role named analyst has on the table products. That would allow a user to return all of the privileges a role named analyst has on a table products. Oh, so select grantee and privilege type from information schema table privileges where grantee equals analyst. It's not roles, is it? No, I don't think so. Yeah, there we go. You're a super user who just created a role Evan with the statements below. So create role Evan with login, and then we gave him create DB. Which of the statements below will throw an error? Set role Evan. create database test. That should be fine. Set role Evan. Create role Alice. I think it's this one because we didn't give him the ability to create roles. Yeah. Which of the following actions would be inappropriate for a database super user to perform? Creating a new role in the database for a new engineer or analyst who just joined your organization and granting that role the ability to select on all schemas. I mean, that might be fine. Running a query that selects from 2 tables and joins the response to display on a dashboard. That's fine. Set role into any login role to test a role's permissions. That's fine. Altering the default privileges in all schemas in the database to allow new tables to automatically allow employees the ability to select. I think it's this one. Nope. Running a query that selects from 2 tables and joins the response to display on a dashboard. Why? Which of the following actions would be inappropriate for a database super user to perform? But what? This is a task. This task would require ownership of all schemas in the database, which a super user would have. So, okay. This is a nonsensical question. Most PostgreSQL database clusters are created. No, you cannot go there. Most PostgreSQL database clusters are created with a default role that has super user privileges and can modify all access restrictions within the database. What is the name of this role on most systems? Postgres. Yep. Which of the following will create a login role named Alice with no super user privileges but with the ability to create roles? So login and create role. Fill in the code below to finish the query that would allow a user to return the names of all roles in the database that have the create DB privilege. So select role name from PG roles this time, where role name equals true. No. Where role create DB. Yeah. Okay, so this is a task that could be made safer by creating a non-super user role with a select privilege on both tables. I don't get it. Like, why is super user doing this unsafe? I guess because, like they said, super users should avoid doing superficial tasks on the database. I don't know. Select the statements below that grant the ability to select on products books to David. Assume David does not have usage on products. So we grant him usage first, and then we grant him select on books. Which of the following statements creates a group role named engineers that cannot log in and has Alice and Bob as members? Create role engineers with no login. Yeah. Fill in the code below to change the default privileges for reader in reports. So alter default privileges in schema reports. Grant select on tables to reader. Yes. You're a super user who just created a role Evan with the statements below. Which of the statements below will throw an error? So set role Evan and create role Alice, because he does not have the create role permissions. Fill in the code to create a valid statement that creates and enables role level security on the projects table. Oh my god. Let's try to remember this. First we have to create a policy, and then we have to enable row level security projects. Employees? No, this doesn't make sense. Oh, it's alter table projects and enable row level security. Yep. Okay, an admin has just run the following query on projects. So he's granting select on specific columns on project schema on projects table to the reader. Which of the following queries can reader execute without receiving an error? Assume reader has been granted no other permissions on this table. So he's trying to select ID description from projects. That should be fine. He's trying to delete from projects. That will probably throw an error. He's trying to select ID start date and description. That should throw an error as well. Insert into projects ID description. Oh, so which one can he execute without receiving an error? So it's this one. Yeah. Alright, fill in the code below to finish the query that would allow a user to return all of the privileges a role named analyst has on table products. So select grantee and privilege type from information schema table privileges where the grantee is equal to analyst. Yep. Okay. I am kind of getting overwhelmed or like brain dead with the privileges stuff. Alright, so we have a... Wait a second. What? This is such nonsense. Like, how do I secure my database? How do I make sure my database stays intact? Unit is supposed to take 21 minutes to get through. We've been here for 5 hours now. Talk about understatement of the year. My God. Yeah, to read maybe. Even then, it's like 21 minutes. But to also do the exercises, even if we minus out my lunch break and my other breaks, it's still probably like 4 hours. Holy crap. Okay. So, data exchange service. This project will involve implementing a PostgreSQL database that's suitable for storing data or a data sharing application. Imagine that your company has created a data platform that allows users to share datasets and the metadata. A few select data publishers have been given access to your database, and you've been tasked with setting up the permissions to allow these publishers to get relevant information about how users are interacting with the data they've uploaded. Okay, so right now the database has just one super user. Write a query that allows you to determine the name of that role. So select, I said select current user. So C user. Okay. What are the names of other users in the database? Oh. So we need the name of that role is C user. Okay, what other users are there? So select role name, I think, and sure, let's do a role name from information schema dot, what was it? Role permissions, something like that. Where were you? Show yourself. Security with roles. No, not the quiz. It was information schema column privileges. No, it was PG roles, I think. PG catalog, PG roles. Role. Super. PG catalog, PG user, was it? PG roles. Okay, so what are the names of the other users in the database? What permissions do these roles have? What if we select everything? Ah, there we go. Okay, so CC user has everything. And all the other ones, well, okay, signal backend has the role to inherit. PG monitor can inherit and create. No, just inherit as well. Okay, they can all inherit. FT is a weird choice for representing these, but I know it's true and false, but still it's difficult to see exactly which one's T and which one's F because they're similar. Okay. So now that you have the name of the super user, check the name of the role you're currently using. Is this role the super user? Yes, he is. Because we already checked it. Okay, in this section, we'll add a role for our first publisher, ABC Open Data Inc. First, let's create a login role named ABC Open Data without super user permissions. So we do create role ABC Open Data. What's the syntax? With. Yeah, okay, so with login. So that should be that. And if we take a look at the PG catalog, PG roles again, ABC Open Data is here and has a login role. Okay, that worked. Now let's create a non-super user group role named Publishers and include ABC Open Data as a member. We can add multiple publishers to this group role and then manage their permissions by modifying this role. Okay, so we do create role publishers with what? Create role David with login in role. I'm still sort of unclear about how you create groups. Because technically, this should create a group. Because here we created a group PGDBA. And we put David in that group. Okay, we could do login. And instead of creating ABC Open Data here, we could enroll. We could create this up over here and do just in publishers. And if we take a look at the roles that we have, oh, what if we just have an empty with? No. Fine with login. Still no. What? We have publishers here, but we're not inserting this. Group membership. So using create role and the with role option when creating a role, this automatically adds the listed names to the role. Oh. So maybe we shouldn't have done that. We should have just do this and then publishers. So the keyword is with role. So we do with role and then we add ABC. Open data. Yeah? Okay, so ABC open data. They don't have the role to... Oh, they do. Have the role to log in. Yeah, makes sense. But publishers don't. Okay, I will assume that I've created a group. I don't know. Create role, grant finance to Charlie. Grants all permissions of the newly created role to the listed names. You can also add users to groups on creation by specifying in role along with the create role statement. So, oh, automatically adds the listed names to the role. So I don't understand what's the purpose of like with role if in role does the same thing. Also add users to group on creation. Using with the role option when creating a role, this automatically adds the listed names to the role. So it does the same thing. Okay, let's not question it. Let's continue. Okay. So there's a schema in the database named Analytics. All publishers should have access to this schema. Grant usage on the schema to publishers. Okay, so grant usage. Let's remind ourselves of the syntax. Where was the usage thing? Not here. Not. Oh, it's here. Okay, grant usage. Create on schema. To analyst. And then grant select. Ah. Create on schema. Without usage, a role cannot access tables within that schema. Our schema level permissions include create and drop, which allow the grantee the ability to create or remove tables in that schema, respectively. Oh, so granting usage is not enough. After that, we have to specify what kind of usage. Either select, update, delete, or insert. So create, what was it? Create on schema. On schema. Analytics. 4, 2. 2 publishers. Oh. Grant usage. Oh, needs a comma. For some reason. It's weird. Okay, so publishers now. It's just a role. So never mind. There. Now that publishers has usage, write a query that grants publishers the ability to select on all existing tables in the analytics. So grant select on all tables in analytics to publishers. Is that correct? Grant select marketing prospects. I think I could do on all tables. Grant select on all tables in finance to analysts. Yep. So no commas needed? No. So that should work. No. Syntax error at or near analytics. Do we need a comma here? No. on all tables? Yeah. Relation analytics does not exist. I'm misspelling analytics. No, I'm not. Grant usage on analytics to publishers. Relation analytics does not exist. What are you talking about? Because when I was giving it the create grant, and that was fine. Grant usage, create on schema. Like grant usage. Sure, create on schema. What? Oh, comma. But we still have... this problem. On all tables... without default privileges, anytime user creates a table... Wait, this is default privileges. So... table specific permission. But okay, we want us granted on all of the tables. Do we need to specify it? Like, okay, select on analytics to publishers. Relation analytics does not exist. Can we... okay, analytics... where's the... okay, let's comment this out. Let's take a look at what in the hell is going on in analytics. Select all from analytics. Does not exist? What are you talking about? Create schema analytics. Alter. Create schema directory. Create schema. Alter schema. Create a table. Downloads. Okay, sure. Let's do downloads. What? So we can't access anything? Publishers the ability to select on all existing tables in analytics. Do we need to do this with the default? No, but it shouldn't matter. Like, this should work. In analytics to publishers. I literally just copy pasted this. Alright, let's copy this too, I guess. Nope. Grant select on all tables in analytics to publishers. Grant usage on analytics to publishers. That's literally what you're telling me to do. Where's the usage stuff? So, grant usage, create on schema, marketing to analysts. Okay, let's do it this way then. Analytics to publishers. And then we literally just copy paste it into here, except this. And instead of marketing prospects, we do analytics to publishers. So is this the way? No. Maybe it's the comma? No. What is going on? Okay, so this worked because we're selecting a specific table. And what if we do on all tables? Nope. Because all tables uses on all tables in analytics to publishers. Hmm. I don't know. I'm lost. This is modifying default permissions. This is modifying permissions on existing schemas and tables. Maybe we need to reload this. I don't know what's happening. Oh wait, no, not this. DB. Role CC user does not exist. Yes, it does. Alright, let's try to copy this and then reset the workspace. Because something is off. I don't know what. Try this. Nope. Same stuff. Now the publishers has usage. Write the query that grants publishers the ability to select on all existing tables in analytics. Is it grant? It's grant. Cannot access tables within that schema. Other schema level permissions include create and drop, which allow the grantee the ability to create or remove tables in that schema respectively. To interact with the table, a role must have usage on the table schema. Okay, we already gave it usage. Additionally, a table owner must also grant select, update, delete, and insert. Well, I am the table owner, I assume. As the owner of the scheme of finance, perhaps you'd like to grant the ability to select and update a table named finance revenues to a user named analyst. All right, let's go to chat. BGBGBDB. How to grant select or a select privileges on a schema to a group called analysts. No, publishers. Publishers in PostgreSQL. Okay, so we create a group, grant select on all tables in schema. What to group? I doubt it. to group. Grant usage on schema. Sure, let's try it. Grant usage on schema analytics. To group publishers. Okay, that did something. And then we do this. Grant select on all tables in schema analytics to group publishers. Okay, so that worked. Where is a single mention talking about to group? There's not a single use of the to group in here. Okay. I guess things changed. Or something. Maybe the PostgreSQL syntax changed or something. I don't know. Alright, so check to see how PostgreSQL has recorded the changes on the schema permissions you just updated. Query the information schema table. So select query the information schema table privileges to check. Okay, just select all from information schema dot table privileges. Oh my god. Okay. There's too many. Let's do where where grantee equals publishers. It's probably in publishers. Okay, so they do have one privilege to select in analytics. Grantee publishers, grantor C user. Okay. So it worked. Let's confirm that open. Oh. So we have publishers. What about ABC open data? No, they're not here. Okay. Let's leave that open. So let's confirm that ABC Open Data has the ability to select on analytics downloads through inheritance from publishers. This is important because we want to manage most publishers' permissions through the group role publishers instead of the role of each publisher. Set your role to ABC Open Data and try to query below. Okay, so set role to ABC Open Data. And now we try to select everything from analytics.downloads. Limit to 10. Okay, so we can. All right. Let's set our role back to role CC user. Okay, so granting a publisher access to dataset listings. There's a table named directory datasets in the database with the following schema. Select from this table to see a few sample rows. Sure. Okay, select all from directory.datasets. Oh crap. Limit to 10, please. Okay. So ID, create date, hosting path, publisher. All right. Grant usage on directory to publishers. This statement should be almost identical to the way we granted usage to analytics. Okay. So we do, instead of schema analytics, we do directory. Okay. Let's write a statement. Let's write a statement to grant select on all columns in this table except data checksum to publishers. Let's remind ourselves how we do that. Wait. Oh. Wait, where is directory then? Because, okay, is it? I thought it was a schema. Oh, it is a schema. So... Okay, so on directory datasets, grant projects. We want to grant select on all columns of this table except data checksum to publishers. Okay, so we have to first grant select. We will do directory.datasets, right? Yeah, to publishers. And then we want to update grant update, I mean. Grant update. And we will do ID. On everything except data checksum. So create date, hosting path, crap, publisher, and the src size on projects, on datasets to publishers. Relation datasets does not exist. On directory datasets then? Maybe. Okay. Okay, let's mimic what might happen. If a publisher tries to query the dataset directory of all dataset names and paths. Okay, so set role to ABC open data. And then we try to select ID, publisher, hosting path, and data checksum from directory dot data sets. Nope, we got it. Damn it. Why is this query failing? Can you remove column from this query so that it's successful? It's not failing though. It's not failing. We didn't restrict it. No, it should be with column level security. Okay, why are we doing it like that? Instead of messing around with this whole shebang, right? We can just grant select. Wait, but how does he know which table this is for? Wait, does it matter? On projects. Projects is a table, but we can do, instead of projects, we can do directory datasets and to publishers, right? And instead of these things, we can do do ID, create date, hosting path, src size, publisher. Yes. So technically, if we run this now, Okay, that's correct. Can you remove a column from this query so that it's successful? So if we delete data checksum, we will know that it works. If it doesn't give us an error. Yep. Okay. Adding row level security on downloads data. Although we're designing a collaborative data environment, we may want to implement some degree of privacy between publishers. Let's implement row level security on analytic downloads. Create and enable policy that says the current user must be the publisher on the dataset select. So I definitely need to take a look at how to do that. Alright, we could just... Okay, let's write it. So. Okay, you move over here. You move over here. You move over here. Wait, no, I meant to do it the other way. You move over here and you move over here. Now I can open... Damn it. Okay, no, the other way around. You move over here and you move over here. Okay, there we go. So let us create the row level security policy. So create policy. Let's do like publisher row security or something on analytics downloads. Wait, no. No. Create a name policy. Security user must be publisher of the dataset to select. So on publishers or select, right? And then to no. This is not on publishers. This should be on analytics.downloads or select to publishers using publisher must equal current user. Okay, so technically that should have created the policy, and then we want to alter the table of analytics downloads and enable row level security. Must be owner of relation downloads. Oh, I haven't set my rollback to CC user. Column publisher does not exist. Oh. So just... Oh, column. Column? That's for column? Oh, so we do just publisher? What? Alright, let's take a look at this frickin' table. Okay, so this should be owner. Owner using bum 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 bum. Role. Owner does not, but publishers does. Column publisher does not exist. Oh. There we go. Okay. So that's done. And write a query to select the first few rows of this table. Now set your role and run the same query. Alright. So... Oh, sorry guys, got a call. Alright, my other package is coming. Very package-filled day. So we alter the table. Wait, what were we supposed to do? Select a few rows of this table. Okay. So select. Sure, everything from analytics dot downloads. Let's limit that to 10. So we got this. But now if we set our role to ABC open data and run the same query, we should be getting something else. Aha, we're only getting stuff related to our stuff, related to the role that we are in. Okay, well, it's a good overview of privileges and whatnot, but inevitably, if I ever use this, I will probably have to look it up once again, because this is a lot of information. Okay, so we're jumping into ACID. When working in any database, the units of work can be measured by transactions. Transactions are a single task that is being performed on the database. These transactions must contain ACID properties, which is what will be discussed in this article. All right. So what is a transaction? When working in a database, any single unit of work done to the database is defined as a transaction. These transactions can often be made up of multiple different steps, and most of the time represent changes made to the database. To reduce the number of errors that can occur when working with transactions, these transactions must contain ACID properties. These ACID properties are rules that the transactions must follow. In this article, we will use the following as a representation of transactions for our examples. So a write in these examples could be something like an insert statement, while a read could be something like a select statement. What is T1 though? Okay. When working with database transactions, ACID properties will more than likely be discussed. ACID is an acronym meaning atomic, consistent, isolated, and durable. These properties help ensure that all the data in a transaction is complete, accurate, and has integrity. These properties also assist in recovering databases in case of a system failure and allows for concurrent use of a database. Okay, so an atomic database transaction. The first property that we'll discuss in this article is going to be the term atomic. The definition of atomic when discussing ACID properties, according to IBM, is all changes to data are performed as if they are a single operation. That is, all the changes are performed or none of them are. Okay. This means that we treat each transaction as a single operation. Sure. If a single task in the transaction fails, then the entire transaction will fail. For example, let's look at the following transaction. So T1, I assume, is transaction, and then these are the actions. If any steps, If any of the steps in this transaction fail, then the entire transaction would fail. If we go through steps 1 and 2, and then step 3 fails, the entire transaction would fail, and all the steps would be reverted back to the original state before the transaction. In this case, that would mean that even though the writing of item 2 worked, that write would be reverted. Okay. So transactions use atoms to perform operations. Consistent. In any database, certain rules can and will most likely be put in place to make sure that all of the data within is valid or consistent. Transactions must follow these rules in order to maintain consistency. IBM defines consistency as data is in a consistent state when a transaction starts and when it ends. This is a pretty vague definition, but will make sense once an example is displayed. So inside a banking application, whenever money is transferred from one account to another, we need to make sure that no money was lost or added to the transaction. To do this, we would add the funds from both accounts together and store that value. Transfer the money, then add the account values and check the initial value to make sure both are equal. Okay. So save AC1, AC2 as initial value, transfer $20 from AC2. Okay. And then check if that still equals the initial value. These rules can be a number of different things, with some as simple as making sure that the primary index is unique for each row. Others can be more complicated, but no matter what, these rules need to be followed for a transaction to maintain consistency. Okay. Wait, what? Okay. Isolation. When working with multiple transactions that could occur at once, it is important to ensure that when one transaction is reading or writing from a location into a database, no other transaction is reading or writing from that same location. This process is called isolation and is defined by IBM as the intermediate state of a transaction is invisible to other transactions. As a result, transactions that run concurrently appear to be serialized. Okay, for example, if we had one transaction changing a row in a table, and another transaction trying to read data from that same table, these two transactions would not be able to operate at the same time. Instead, these transactions would execute one at a time. Okay. If these two transactions were to occur simultaneously, problems could arise with item 2. Even though T2 writes item 2 after T1, if everything executes faster in T2 than in T1, errors could arise from both transactions trying to write to item 2 at the same time. Because of this, T2 would not execute until T1 is finished executing. This does not mean that we cannot perform multiple transactions at once. We can still have multiple transactions happen. It's just that no two transactions can read or write from the same location at the same time. Otherwise, we could encounter issues where a transaction could use old data, or a transaction could overwrite new data with old data. Okay. And finally, durable. When we talk about transaction being durable, we will use the IBM definition of durable, which is after a transaction successfully completes, changes to data persist and are not undone, even in the event of a system failure. These failures include instances of service outages and crashes. Durability can be achieved through a number of methods, including changelogs that are referenced whenever the database is restarted for whatever reason. What? Protect the database from system failures, then? Okay. When working with the database, we know that when a transaction takes place, the transaction needs to maintain its ACID properties. Those being atomicity, consistency, isolation, and durability. Atoms are consistently isolated and durable. Atoms are consistently isolated and durable. Atoms are consistently isolated and durable. Okay. While methods for implementing ACID properties into a database weren't covered, knowing what this acronym is and the concepts behind each property is a good start. Yay! So what does ACID stand for? Atomic, consistent, isolated, and durable. Whew. SQL injections. Pretty sure we've seen this meme on stream at some point. Okay. So in this article, you'll learn various SQL injection techniques and strategies. Oh my god, there's so many. And strategies to mitigate these attacks. I would take a break, but I'm waiting on a package, and I want to take a break when the package is here. Which should be momentarily. It's been like 15 minutes. The guy said he's showing up in 15 minutes. Because we were due for a break about an hour ago. We're really going breakless today. Okay. So when you log into Codecademy, you provide a username and password, which are used to authenticate you. But how does this work under the hood? When you provide these credentials, Codecademy server will take your input and compare it against user data inside a database. that step of checking the input against the database can be abused by attackers. Through a cleverly and carefully crafted input, an attacker can inject code directly into the database query, getting precious data. In this article, we'll be talking about SQL injection, which is this type of attack on an SQL database. You will be introduced to different types of SQL injection attacks and basic ways to mitigate them. So what is an SQL injection? Well, it's a common vulnerability affecting applications that use SQL as their database language. A hacker can use their knowledge of the SQL language to cleverly construct text inputs that modify the backend SQL query to their liking. They can force the application to output private data or respond in a way that provides intel. Using the following injection techniques, threat actors may be able to access information they shouldn't have, change database records, or even take complete control of the system. Okay, so we have union-based injections. Union-based injections leverage the power of the SQL keyword union. Union allows us to take two separate select queries and combine the results. Union-based injections can allow an attacker to quickly steal information from a system. Let's look at an example. Say this is how the query is created when a customer searched for a product name. Okay, so we have select product name, product cost, product description from product table, product name equals user input. Okay. If the attacker enters a user input such as this, soap, and then union select username, password, blah, 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 blah. This input would create a valid SQL statement that grabs information for soap, but unions all the usernames and passwords of the users. Why would you store your select from user table? Well, I don't know if user table is the best name for the place where you store usernames and passwords, and you probably wouldn't store your passwords like that anyway. You probably have them hashed. So all he would really get is okay, finally. Package is here, 10-minute break. Let's push out the last couple of hours for today, and then I'll be able to get into my little packages. Alright, so we were reading about injection. Right, union-based stuff. This input would create a valid SQL statement that grabs information for soap, but unions all the usernames and passwords of the users. Notice the strategic placement of the whatever the character is that allows the attacker to insert SQL syntax and extend the SQL query. From blah 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 soap. Wait, okay, where does the first one thing come from then? Oh, user input plus this? Why? Okay, well, whatever. Then we have error-based injections, where in an error-based injection, an attacker writes an SQL query to force the application to return an error message with sensitive data. Let's take a look at the example below with an actual vulnerability. In this example, the attacker's input causes an error that spits out the password. Okay. Union select one x blah 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 blah. SQL completes that inside statement, getting the password for the profile ID 1, but errors on the value type that should be returned. This is an error that accidentally gives away the password. I mean, it's only if you're storing your passwords in unsafely. I'm assuming. Then we have Boolean-based injections, which involve SQL statements that can confirm true or false questions about the database. When using this method, the attackers take note of the difference in the application's response, changes in HTML, HTTP response code, or other web session data, when the results of their question are true or false. Suppose a website has a search box that will return the username and email of a specific user ID. The SQL query below is used. So select username email from users where ID equals user input. In a normal search for ID 1, the website will give back the username admin and email admin and display everything as normal. Someone sneaky can use the AND keyword to see what happens on the website when the SQL statement is false. For example, if the search input was this: 1 and 1 equals 2. And this was the SQL query that would run, where ID equals 1 and 1 equals 2. We won't be getting a username and email back since 1 is never equal to 2. At this point, the attacker makes note of what happens on the website when the statement is false. The attacker would also make note of what happens when the modified SQL statement is true. Okay, using this technique with the AND keyword, the attacker could write in any Boolean statements on the other side of the AND, and based on the website's response, figure out if the statement is true. Boolean injections are often used to figure out the name of the database table, possibly to build up for a union-based injection, manipulating one query at a time to confirm one character at a time. Okay. Then we have time-based injections. Not all SQL injections will provide visible output. A time-based injection makes use of several built-in SQL functions such as sleep, benchmark to cause visible delays in an application's response time. While the output of a command isn't visible, delays in response time can be used to infer some information. Suppose we have a database query that will check to see if a certain user exists within the database. Okay, so select ID from users where username equals user. Someone could write this SQL syntax as a text input to confirm if the admin's password is password. Could they? Or if admin equals password sleep 5, no. So making making the SQL query username equals admin Okay, so if there's a 5-second delay before a response from the server, an attacker could confirm the admin user had a password of password. But these only work, or like majority of these work, if you're storing your passwords just badly in a database. Out-of-band injections are generally the rarest and most difficult injections to execute for attackers. Unlike the other methods which return the results via the web application, an out-of-band injection will leverage a new channel to retrieve information from a query. Generally, these SQL injections will cause the database server to send HTTP or DNS requests containing SQL query results to an attacker-controlled server. From there, the attacker could review the log files to identify the query results. Again, these injections are extremely difficult to execute. They rely on permissions to database functions that are most often disabled and would have to bypass firewalls that might stop requests to the attacker server. Yeah, no kidding. Okay, so while testing a web application, you try out an SQL injection into input boxes. You find you're unable to get visible output, but you notice that you can cause the database to delay its response. Which type of SQL injection would you use to gather additional information from this database? Time-based? Yep. While working as a cyber consultant for an organization, you learn an attacker recently breached their database. While looking through the web's request logs, you see thousands of requests containing queries with sleep command. What type of injection did this attacker likely use? So time? Yeah. Okay, so sanitization. Sanitization is a process of removing dangerous characters from users' input. When it comes to SQL injections, we would want to escape dangerous characters such as these, and these. These sorts of characters can allow attackers to extend queries to output more data from the database. While this does provide a layer of protection, this method isn't perfect. If a user finds a way to bypass your sanitization process, they can easily inject data into your system. Additionally, depending on your query, removing certain characters may have no effect. Therefore, this shouldn't be your only defense mechanism. Okay, then we have prepared statements. Writing prepared statements in backend code is common, reliable, and secure solution against SQL injections. Prepare statements are nearly foolproof. How does it work? We provide a database, the query we want to execute in advance. First, the database processes our query. Then we pass in the parameters and user input. Any input, regardless of whether the content has SQL syntax, is then treated only as a parameter and will not be treated as SQL code. Okay. So we're getting user input. I don't understand this. This is PHP. In addition to providing added security, prepared statements also make queries far more efficient. Okay. Which of these is the benefit of prepared statements? Improve query efficiency while also adding additional security when implemented properly. Yep. Alright, let's move on. I'm getting a bit slow today. Lots of information. Crap. We still have a good chunk. Yeah, we have indexes. We have introduction to indexes. We have bookstore indexes. Oh my god, intermediate indexes. We have 2 projects. Okay. Okay, how about for the rest of today, we just do some SQL exercises where we checked, where was it? Lost at Sea. Let's take a look at this. So we close this. Okay, we can type in, let's say, Paul. Designation captain. Play intro. Okay, let's do learn. Lost at SQL. Okay. So, chapter 1. You wake to an ear-splitting screech. You're Captain Paul of the SQL, and you're in big trouble. All you remember before you lost consciousness is an explosion and your path being blocked by falling debris. Now, you know that your submarine is sinking further and further into the icy black depths of the ocean. Somewhere in the distance you can hear the sound of water falling on metal. You can just reach one of the computer terminals. Your only chance it to use it for free. Your only chance is to use it to free yourself and repair the ship. First, you need to know what the damage is. Start by getting all the issues from the table malfunctions. For guidance on how to play, click the I button at the top. Okay, where do I write this? Oh, we run this here? Either delete this whole column or start editing it. Okay. So we need to get all the issues from the table malfunctions. So select issues. Okay, let's do issues. No. From malfunctions. Okay, this is interesting. Let's run the query. Alright, so we have damage escape odds, leak on deck 14, leak on deck 15, leak on deck 16, engines offline, cameras offline, upper walkway flooded, lower walkway collapsed, and oxygen leak. Okay. Let's continue. Some of those problems are inconvenient, but others, every time you set off, you make a deal with the ocean. It won't kill you for as long as you don't give it a chance. Right now, it has a few chances to snuff out everybody on board. You urgently need to check on your crew, but first you need to know how many of the problems you see are the ones that anyone can fix. Using malfunctions table again, get the issues and fix columns. Okay. Why is this thing so small now? So select issues and fixes from malfunctions. Okay, so we have damage escape odds and there's no fix. Leak on deck 14. We activate bilge pumps. For the offline engines and offline cameras, we reroute power. Okay, for upper walkway flooded, we also activate bilge pumps. Lower walkway collapse, there's nothing. An oxygen leak, we seal deck 12. Okay, so activating bilge pumps will give us most, then rerouting the power, and then sealing the deck 12. Okay, let's continue. Another ship-wide alarm starts up. Deck 12 is losing oxygen fast. You can feel your eardrums rattling with noise. You can just see through the porthole a shark dart away as your vessel keeps sinking quickly through the depths. Your ship is never coming back to the surface. The ship is never coming back to the surface. The only hope is escape. You strain against the debris pinning you down. Feel yourself move forward an inch and freeze as the metal above you shifts in warning. This is as far as you go, but you can still help your crew. Get all of the columns from the crew table. Okay, so select all from crew. Okay, we have a lot of crew. Living, injured, living, deceased, deceased. Alright, let's continue. You scan through the list of crew on your ship, heart sinking as you see the names already listed as dead. Who's updating the database? You need to contact your second in command, Helga Sinclair. Luckily, the internal radio has fallen on the ground and is just out of reach. Hopefully, it still works. If you push forward to grab the receiver, there's no telling how long you'll have before you're crushed by the weight above you. So you need to know what number to call before you make any move. You turn back to the Lister crew. You need to find out what deck Helga is on. You have two options. Get all of the columns from the crew table where the role is first officer, or get all of the columns from the crew table where staff name is Helga Sinclair. Well, we could do the staff Sinclair approach. So select all. Select all from crew. Where staff name equals Helga Sinclair. Okay. So she's on deck 15, which currently is being flooded, I think. Okay. You inch your way forward, feeling the white-hot pain across your shoulder as jagged metal scrapes across it. You grit your teeth, not willing to make a noise in case it brings everything crashing down. Your fingers are brushing the receivers when you feel yourself being pulled back in. Your belt is caught on something behind you. Nothing for it, you squeeze your eyes shut as you grab onto a metal seam and pull yourself forward the last couple of inches. Something behind you shifts. The metal rumbles, then, for a moment, everything is still. Sinclair's voice sounds tiny and far away. Captain. Is that you? Where are you? Oh my god, I'm getting a lot of notifications on my phone. You aren't sure. Some kind of explosion. We'll get to the bottom of it when everyone is clear. We have to get everyone off this ship. Thor is going crazy. Sounds like Sinclair is struggling to hear what you're saying, but after a moment she answers. Understood. Captain, the terminals are all down on this deck. We can see information on the screens, but can't change it. Some of the pods don't look seaworthy. We're out of range for others. There's some missing. You put your suspicions aside for now. Got it, Sinclair. Watch your screen. I'll get you a list of pods you can use. Okay, so get all the columns from the pod list table where status is functioning and range is more than 1500. Okay, so select all from pods list. Nope. Pods list. Where status is equal to functioning and range is greater than 1500. This should work, right? Yeah. So we have 4 pods. Okay. Use multiple work conditions. You hear Sinclair shift her headset to look at the screens. The pod information is coming through, Captain. We'll start with the pods. She cut off by a scream and the crackle of electricity. White noise bursts out of the receiver for a moment, and you instinctively jerk your head away, tensing up as the metal above you groans another warning. You hear Sinclair fighting her way back to the phone. Captain, it sounds like she's in pain. Something's gone wrong with the pod 3. Some kind of short circuit. We can get in and fix it, but there's electrified water flooding across the floor. Got one of the crew. We need to know what circuits we can shut down. Water pouring in through every crack it can find and faulty wiring. You're not leaving this one to chance. Sinclair, I'm sending you a list of circuits to switch off. Everything going to pod 3. And any other circuits that aren't confirmed green. Let the crew know. Will do, Captain. In the fraction of a second before she puts the phone down, you can already hear her voice raised, yelling instructions to crew over the sounds of crashing and alarms. Okay, so we need to find all of the circuits where area is pod 3 or status is not green. So let's select again. Select all from pod. Wait, what was it? Circuits? Oh yeah, select all from circuits. No. Circuits. But I'm trying to think now, like area. Okay, maybe it does have area. Where area, yeah. Where area equals pod 3 or status is not equal to, or status is not green, so it does not equal to green. That should work. I'm dubious about the not equal, but oh, it worked. Okay. Wait, this is me. Yep, much better. Alright, let's continue. When you hit the button, for a moment everything around you is plunged into darkness, silent apart from the roar of water trying to force its way into the ship. The alarms come back first, accompanied by the oppressive red glow of emergency lighting. You suddenly feel quite alone. Picking up the phone, you dial Sinclair again, making sure your voice is confident and strong when she picks up. Sinclair, all okay there? Again, when she answers, you can hear how distracted she is, fighting against chaos on her end of the line. We got access to the pods again. Thank you. I'm going to send parties to gather the last of the crew and to come and get you. Can you still see where we've got people? Focus on the crew first. You say as you turn back to your terminal. I'll tell you where to go. Okay, so we need to find out how many crew are in different places. Count the staff name column grouped by the last location column. Call your new staff count column crew count. Okay, so we have access to the crew table, and we need to select. We need to select count. Count rows, I guess, as crew. count. So count the staff name column. Oh, staff name. Okay, staff name. Grouped by the last location column. Okay, so from through grouped by last location. Oh. So we got the crew count. Oh, we also need... I guess last location? Yep. So we have the most people in deck 3, followed by deck 2, then deck 5, then deck 1. Yeah, okay. Sinclair's parties are wading through the flooded halls, drawing their crewmates back to the escape pods. Even with the information you're sending through, they are fast running out of time. You've got to make a call. Okay, Sinclair, call the parties, tell them to leave the dead. Prioritize the injured and tell anyone healthy they have to make their own way to the pods. I'll send you through... Oh, I'm getting another call. 1 second, guys. Okay, my second package is arriving. Alright, so, I'll send you through new numbers to prioritize the floors. So you're not sure if she can hear you over the clamor end of the line, but you shout it over anyway. Do not send anyone for me. Do you hear me, Helga? No response. Okay, so we need to find out how many of the crew are in different places and what different states of health. So we need to group by the last location column and the status column. Count the staff name column and call it crew count. Okay, so count the crew based on their last known location and their status. Use the staff name column in your count. We could use any column to count, but we're going to use staff name. Yeah, I was interested. Like, why did they pick count name specifically? Or like the crew name, but okay. So we want to select, first of all, we need status, and we need last location, and we need a count of staff name. So from crew, and we want to group by as crew count. So we want to group by status and crew count. I think this is correct. No. Looks like you're grouping and summarizing without giving your summary columns name. Make sure to name them using as. For example, select some sales as total sales. I did. Aggregate functions are not allowed in the group by clause. Oh, my package is here. 1 second, guys. It is mandatory in this household to let Thor sniff all the new items that come in. It's a rule. You have to do it. Otherwise, you're, I don't know, you're the most evil person known to man. Okay, so aggregate functions are not allowed in the group by clause. But... oh, last location and status. Never mind. Last location. There we go. Deceased. Okay. Brum, 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 brum. There is a banging at the door. The sound of people trying to force their way in. With each crash, you tense, expecting the house of cards above you to come crashing down. Stop, you yell. Unheard over the voice. You pick up the receiver again. Sinclair, tell the team outside my room to focus on others. I'm not getting out of here. There's an uncharacteristic pause on the other end of the line. You start to think she can't hear you. Sinclair? Captain, That's an order, Sinclair. You're not losing any more of the crew, and I can do everything you need from here. Are we ready to evacuate? You almost hear her snap herself out of it. We've got access to the pod again, thanks to your information about the circuit breakers. The groups are coming together, but we've got people scattered across the ship. We could use some help figuring out if any of the pods are much heavier than the others, or if the crew are very far from their pod. I think we're going to have to take some risks when we launch, but the sooner we do, the less risky it'll be. So, we need to group our crew based on the pods they're heading for. To find out if any of the groups have particularly high total weight, to find out if any groups have a particularly high total weight, or are particularly large or far away from their pod. Okay, this one will be toughy. Okay, so we need to... What do we need? We need... group everyone by pod group, but only if their status is not deceased. Sum their weights and call it total weight. Okay, so select. We need to sum weight in kilos. Total weight are particularly large. What have we got inside here? Staff name, staff ID, last location, status, role, weight, pod group, distance to pod. Group everyone by pod group. So we got the weight covered, are particularly large. I guess we just get weight to kilos. And far away from their pod. So also some... Get an average maybe? Average out the distances. So this one should be as total weight. Oh. It should be max. As max distance. But I still don't get... Well, we also need status, right? Status. No, we don't necessarily need status, because we will just exclude that anyway. Status is not deceased. Sum their weights. Call it total weight. Find the max distance from pod. Call it max distance. Okay, so maybe we don't need the weight in kilograms. From through. And then we just group by well, we also need where status is not seized. And we group by pod group, but only if their status not seized. Okay. So will this work? Status group variable pod group. Let's sum their weights. Call it total weight. Find max distance from the pod and call it max distance. No. Pod group. Oh, we also needed pod group here. Okay. Okay, let's continue. The maximum weight for each of the pod bays is 1,000 kilos. Usually this means to include space for gear and backup recordings of everything on the ship. Even with leaving a lot of that behind, some of those groups are too heavy. Sinclair, a couple of those groups are too big. A pause. When Sinclair speaks, you picture her waving off someone who's trying to get her attention. It might be worse than it looks. One of the medical officers has just told me some of the crew members have their weights down wrong. It was on the list to fix it, but they missed an O. They're down as 10x too light. Oh. Okay. So that kind of difference could sink a pod. Somewhere you hear cracking noises, and picture water starting to force its way through the failing window. In a moment of weakness, you think some people who couldn't do simple admin should drown at sea. Okay, wow. Okay, I'll check if that's a problem. Okay, so we need to see if any of the crew are down as suspiciously light. Select the name and wait for your crew and order the list by weight from low to high. Okay, that's pretty simple. So select name? No. Crew staff name. Select staff name and weight in kilos from crew. And we wanna order by weight in kilos, descending. Think so? No. Ascending. No, there's no such thing. We just run the query. Yeah. Oh, that's quite a few of them too. Renee Zellweger is here. George Davis, Martin Michaels. Samuel Mendez? Kate Blanchett is here? What? What is this submarine of celebrities? Okay. Some of the crew are down as weighing less than 10 kilograms. You're right. You say down on the phone. Some of these weights are definitely off. The ink black sea is swallowing you, your ship, and a couple of hundred crew, and you're doing admin. But at times like this, it's too risky to leave anything to chance. Normally, if there's a seat in one of those pods you can put someone in, there's enough margin for error, that pod will make it work. But with all the damage to the ship, the pods that are left will definitely be overfilled, and given how deep the sub is already, a pod that's too heavy may well never reach the surface. Sinclair? Yes, Captain. You can hear from the sounds of rushing water and distant shouting that they're fighting a leak and preparing to seal off another section of the ship. I'm going to adjust the weights. I will get you the new group soon. How long do we have? We're on borrowed time here, Captain, but if you need it, we'll borrow more. Even as you put down the headset, you hear her yell, "Officer Laws, get the team bailing out of that pod. We can't drag half the sea with us to the surface." Alright, so we need to fix the weights for the crew members that are down wrong. Select the name and weight for your crew, and create a new column called Fixed Weight. Okay. So we do select crew name or staff name and weight. And also we need a new column called Fixed Weight. Okay. So from crew. But okay, when the current weight column is over 10, then fixed weight should match it exactly. But if it is less than 10, then the fixed weight column should show the weight number multiplied by 10. So do we need an if statement here? Because okay, from crew seems a bit too early for an if statement. I haven't even learned it on Codecademy yet. Alright, let's take a look at learn. So it is very common in SQL to have data that's just slightly wrong. We also often need to categorize data based on a few different conditions. We can use case to make flexible changes to our data. Case is part of the select portion of your query, and the structure of case is case when something we want to check, then result, else. Oh right, case. I think I learned about this. Categorize products by cost. So select product name cost. Case. Okay, so in this case it would be like case when weight in kilos is greater than 10, then okay, let's do this, then fixed weight is equal to weight in kilos, right? Else fixed weight is equal weight in kilos times 10. Cost and as cost category. Oh, so we just do here and as fixed weight. No, we can just do end, I think. But not here. It should be here. Okay, so then we have to order results by weight. Order by weight in kilo, no, by fixed weight. Fixed weight. Order by fixed weight from low to high. Okay. Let's try and run this. No. An SQL has caught it, but lost its SQL doesn't have a friendly error message to explain it. Don't panic, the error below will explain what's wrong. Read it all through, particularly everything up until the last line. Near case, syntax error. Case when maybe it was a comma here, or maybe it's the fixed weight. Everything else seems to be okay. Else cheaper. We have the end statement. Products. Oh, I think we should be doing it like this. Else. Weight kg equals weight kg times 10 and as fixed. Wait. Then we can remove this from here. Okay. No, still not good. But... Ah. Now we only have a problem when... we're trying to match these things. Everything else matches. So... we're getting zeros. Hey, Boggle. I'm doing good. How are you? Welcome to the stream. We are playing an SQL game about a sinking ship, and me using my SQL abilities as a captain. I'm trying to save everybody. Just working? What are you working on? Like at work or at home doing something? Working from home today? Oh. How come it's just today? Do you get to pick? Like some days from home, some days from... Oh, unless you're like a hybrid thing kind of deal. Normally Monday, Tuesday, Thursday in office. Oh, okay, so it is hybrid. Oh, that's cool. I mean, a little sick today and would rather not spread. Yeah, good choice. It's a shame that it's not like full remote, unless you don't prefer that. Because I'd prefer full remote, to be honest. Working on some cron jobs? What are cron jobs? Automated tasks. Ooh. Are you working in like a programming company, or are you using like your programming... Oh, throughout the OS. So probably programming company, right? Yeah, backend. Okay. That's cool. How's it going so far? Kinda everything at the moment. How long have you been programming for? Third year of university, which is full-time work in industry. Oh, that's cool. So you finished comp science, I assume. Been working as a dev for around 11 months now. Oh, that's cool. Go back for my final year in October. Well, it's cool that they have it structured that way. Because when I was doing my finance degree, I also had a little bit of time for like the practical stuff at some kind of company. But they only gave us 3 months, I think. And we also had to find the job ourselves. So what are the chances that they will hire you after this? 18-month contract. Damn. That's pretty good. I assume it's paid too, right? Yeah, it's paid. That's awesome. It's like immediately as you finish your studies, you get a job pretty much. And you have like some practical experience too. Defining the thing yourself kind of sucks, but you know. I wish universities had like contracts with some companies, you know, just like accept everybody. You know? I guess that's like one of the major upsides of going through a university instead of like self-learning is that you kind of get that oh well, I guess it depends on the university too. Where I lived is pretty normal, so it wasn't too hard, especially since I knew my shit compared to my peers. Oh yeah, yeah. It's called uni work placement, pretty common. Yeah, it's common, but I don't know, maybe it was the time where I was looking for practice spots, because the only practice spot I was able to land was at a insurance company. And it wasn't even a good one. It wasn't even paid or anything. It was just basically a pyramid scam for insurance. And damn, I spent like 2 months looking for it. I went through all like finance, accounting, whatever companies in my area. And I couldn't find someone who would accept me. Yeah, it's cheap labor and it's an opportunity for the company to sort of grow and shape a specialist for themselves. So that when that practice finishes, they know that, okay, this person knows our stuff. They know the employees. They can immediately start working instead of having to teach them and train them and the whole onboarding period and whatnot. I'm being molded through the hellfire pits of hell. What is this? What is the tech stack? Now I'm curious. Work with PHP, Go, Perl, bit of Python and Java, then Postgres, MSQL, some DevOps stuff like Terraform and Puppet here. Okay. Bit of Python and Java. Okay. Well, we're currently learning PostgreSQL. I will have to also check out MSQL too. I'm assuming the differences aren't that terrible, because I'm learning PostgreSQL as a thing from Codecademy, but ideally, I need for the job that I'm aiming for, I would need MSQL, because that's what they're using. I love PostgreSQL. Stick with Postgres. How come? Is MSQL that terrible? Just work PostgreSQL mostly and enjoy it. Yeah, it seems fairly similar to SQLite, to be honest, because I did some of that in my bootcamp. So now picking it up seems relatively easy. And the JSON column data type is awesome. able to index on JSON. I have no idea what indexing is yet. We should be picking that up tomorrow, actually. I think if we are able to... Oh, actually, we're on indexing right now. And since we've been learning since 8 o'clock in the morning, I'm just... There's too much information in my head to tackle another major topic. So we're doing this sort of SQL practice little game thingy. Because, yeah. That's what we basically do on the stream here. Since you're new, I can introduce everything. We learn programming. Primarily right now we're learning from Codecademy. And we're learning with the goal of landing a first job. So I've actually been in contact with the company. Went to their interview. And they were like, okay, we could hire you, but you have some gaps. If you plug those gaps, you can come work for us. And right now, that's basically what we're doing. We're plugging in gaps. I said went through finance. Yeah, I did. I have a bachelor's in banking and investment management. But I don't know. It didn't pan out. Just not that interested in finance. After going through through 4 years of university studies. Of course, I would accept opportunities where there would be, yeah, fintech, right up my alley, but no one's hiring. Maybe one day. I did apply to a couple of jobs in fintech, and actually one company contacted me. I didn't even send them a CV. They were like, "Yo, we're this like small startup. We're doing fintech. You don't really need to know much." Apart from what you already know, everything else we could teach you on the job. I was like, okay, cool. And they're like, okay, because you have like finance experience, you have programming experience, and that's the kind of person we're looking for. And I was like, okay, cool, sign me up. Where do I don't even care about the salary, just sign me up for this. And they were like, okay, I will pass your contacts to the hiring person on the company, and they will get back in touch with you. And they never got back in touch with me. So, oh well. Yeah, basically, you know, I don't even care if I get paid. I'm fortunate enough to be able to have enough savings and be financially stable enough to dedicate basically 8 hours a day, 5 days a week to self-learn. So I wouldn't even care if I get paid at this stage. As long as, you know, it's valuable experience, it's something that I'm enjoying to do, and it's a decent company that's dedicated to actually teaching instead of, you know, just using you as free labor. What country? Lithuania. Yeah. So yeah, that's what we are doing. I'm thinking probably gonna take a couple of months to plug all of this, depending on the difficulty of like C and .NET stuff. But we did go through JavaScript already. Picked up a lot of JavaScript from the course, even though it was before the company contacted me. We did finish JavaScript. Now we're just looking at databases and just doing a deep dive on databases. So yeah, that's basically what we do here. Okay. Let's take a look. Not sure how progressed you are, but how are you with Git? Decent, I would say. I mean, I use Git. I use GitHub. I've used it for project versioning purposes on my previous projects, so I'd say I'm okay. I know the basics, you know. When it comes to probably where I would encounter difficulties, would be like with branching stuff. But I know how to do basic stuff like pull, push, commit. Yeah. There will be... Actually, wait. I didn't add it here. But there is a GitHub thing here. So we might pick that up. Basic Git workflow, important Git operations. What do we have here? Backtrack. Actually, this might be useful. So now that you mention it, you know, we might add this to the roadmap. Because I'm imagining, I don't know, maybe the basic operation, maybe the basic Git stuff would be enough at a company. It can be super simple yet super complicated. Oh yeah, I've experienced that firsthand. And then we have part 2, which is branching, teamwork, best practices for repositories. Okay, these don't seem too long. So we might actually add them to the Codecademy branch here. Git and GitHub part 1 and 2. Because it doesn't seem too long, so at least having basic knowledge about it would be useful. Learn majority of my Git skills on the job through stress. It's interesting how much stress can teach you. I've learned basically all of my Excel skills on the job through stress as well. So, because I came into the job, because I was previously working in this company where I started as a basic helping hand, pretty much, and I rose through the ranks to become a line coordinator, which is like a leadership position. Then you have a team of your own, and Excel was a big part of that. So just had to learn everything super fast. Basically dedicating hours and hours off work to be able to do things that I wanted to do. So yeah. Okay. Let's take a look at where we're messing up here. So we're trying to change the weights when the weights are less than 10 kilos. Learning for hours and hours outside of work, pretty much this career path. Yep. And I don't know, like, it seems like it would be a turnoff for most people, but I've been doing this, right? 8 hours a day learning for the past, I don't know, 6 months. And it's at no point was I like, okay, I'm bored of this, or like, hey, this is not fun, or like, F this shit, F this S, I'm just gonna drop everything and move to something else. No. There were some pretty tiring days, but that was mostly due to outside factors. When you're like tired and maybe you had a day where you had so much information that you can't absorb anymore, but then you go sleep it off and you jump into it next day. Yeah, and I'm not even getting paid yet. So, yeah. And streaming actually has helped quite a bit. Like the social aspect of it, it's very, very engaging and very encouraging too. Helps you not lose motivation. Because you have people coming in and you're like, from very beginners who are just like, what is going on, to people with like 10 years of experience, and everybody shares their perspective, you know. Some people help you, some people ask you questions, so you get to help someone and get helped by someone at the same time. And yes, it does help with getting over code anxiety, which I don't think I had much of in the beginning, right? I know I know that I'm a beginner. I know that I'm gonna write bad code. I try my best to write good code, but you know, it is what it is. And somehow getting stuck on something doesn't really stress me out too much. I just work at it, sometimes too much, until it gets solved. Like I think it was the day before yesterday, we had an exercise on which I was stuck for like 4 hours pretty much, until I had to I think it was last week maybe, until I had to tell myself just like, okay, put it down, move on, because there's no point in bashing your head against the wall at this point. Just move on, learn more stuff. Maybe we'll come back later. So when our weight is higher than 10 kilos, then I'm not entirely sure how the case thing works. The case expression goes through conditions and returns a value when the first condition is met. Once the condition is true, it will stop reading and return the result. If no conditions are true, it returns the value in the else clause. If there is no else clause, and no conditions are true, it will return null. Sometimes you just need to go for a piss break or walk. Majority of the time solves the problem. Yeah, it does. That's why we take breaks pretty much every hour. Then we take a lunch break. Breaking is incredibly important, especially when learning, I find, because there's just so much information and you can get burned out really fast. So they have a product name. So when the price is less than 10, they return low price product. When the price is more than 50, they return high price product. Otherwise, okay, maybe I should then make this different. So when weight is less than 10, then weight times 10. Otherwise, we just do weight in kilos. And then we return that as fixed weight. That's why I like going into my office. You can just quickly turn around and look to the person next to you and talk through the problem. Oh yeah, yeah. It's assuming they're working on the same thing, definitely. I don't know. I wish there was an ability to, like, when working for a company, to sort of stream or, you know, show people your work when working remotely. Obviously, that would be a huge problem, but still. Because one of the things that I think I'm gonna miss is just when I find a job is just streaming, because it's been so much fun. Like, I will obviously probably still stream, but definitely not as much. But at the same time, I wish there was a way to stream when working. That would be fun. Okay, so end from products and end as price category. Okay, so this should fix it. No. Ooh, wait. quite a lot of people who do stream on here while working. They just don't show the screen. Yeah, I guess that's one of the options. What's the task here? We need to fix the weights from the crew members that are input incorrectly. So we're looking at the crew table, and some of the weights in there are basically typed incorrectly. So we're selecting staff name and weight in kilos, and we're trying to use case. So when the weight in kilos is less than 10, we have to multiply that by 10. And we need to return that as fixed weight, but I kind of feel like I did it correctly, even though it's saying I didn't. Because it was 5. Oh, it's still returning. Wait. Order your results by weight from low to high. Oh, so just weight, not fixed weight? So we need to fix the weights from the crew members that are down wrong. Select the name and weight for your crew. Done. And create a new column called fixed weight. Oh, okay. We did that. When the current weight column is over 10, then fixed weight should match it exactly. But if it is less than 10, then the fixed weight column should show the weight number multiplied by 10. Okay, maybe we have to just do order weight by descending. No, I don't think that's a problem because it's only saying that some of these are incorrect. Maybe we have to do like then. No. Or no, that doesn't make sense. And as fixed weight, order by weight kilos. If it's less than 10, then the fixed weight column should show the weight number multiplied by 10. I mean, we got it fixed. But wait, it seems the problem might be related to decimals. Wait, show me some more. Or no, actually. Yeah, because 8.1 turned to 81. Okay, we can try doing descending. No. You have the right columns and the right number of rows, but 184 of your 186 rows don't have the expected values. What? It's even worse now. You need to order your results a specific way for this challenge. So maybe the data we got is right, but it is in the wrong order. Well, This didn't work either. No, what? Now it worked? What? It's exactly the same as it was before. Okay, so it might have been some kind of quirk with the platform itself. Because I'm pretty sure... Yeah. Okay, let's continue. Took us a little bit, but we got there. Okay. It seems to be working. Now you have... now you just have to put this together with the grouping steps before to show your crew which groups are too heavy. Sinclair, he's still there? Still here, Captain. If we don't get going soon, we're gonna lose one of the pods, but I still have time to send 2 groups up to get you free. You glance again at... Oh. New tutorial available. What? Okay, no thank you. You glance again at the debris blocking the door. Focus on getting them out, Helga. I'm not leaving this room. So, you need to... Gonna head back to work here? Okay, no problem. Feel free to lurk, or if I'm distracting, see you when you're not working, maybe? Thanks for coming out. Shall throw you a follow. I appreciate that. Thank you for the follow. Good luck at your work. Hope to see you again. Okay, so we need to add together all the aspects from the last few levels. Filter out only crewmates that aren't deceased. Correct the weights and group by pod group. Sum the weights and then filter the groups. Holy crap, to just the ones where total weight is more than 1,000 and ordering by total weight from high to low. Okay. So filter to only crewmates that aren't diseased. So select all from crew. No. Crew. Where status is not deceased. Wait, how do you spell that? Deceased. Like this, I think. What following unexpected headings are in the response? Staff ID, location, status, role, distance to pod. What? That's exactly what we needed to do. Wait, filtering to only crewmates that aren't diseased. So, do we just need names? Staff name. Status role. And we also need weight in kilograms. And pod group. Staff name, weight in kilograms, pod group. Okay. Where status does not equal deceased. Maybe I misspelled it? Oh yeah, you did. With a capital D. Okay, this is fine. Okay, so step 2. We have 2 tables. Using the filtered crew table, select the staff name and pod group. Okay, so select staff name and pod group. Create a fixed weight column which matches the weight column. If the weight is otherwise multiply the weight by 10. Okay, so we basically do the same thing with the case when weight in kilos is less than 10, then weight times 10. Else, weight in kilos and as fixed weight, I think. And as fixed weight. Create a fixed weight column which matches the weight column. Otherwise, yeah. So from filtered crew. Okay. That's a success. We have step 3. Group the fixed crew table based on the pod group. Sum the fixed weights column and call it total weight. So select select sum based on the pod group. So sum fixed weights as total weight, and we also need pod group. Let's actually put it here. As total weight. Sum the fixed weights column and call it total weight. Alright, so we're selecting from fixed crew. No, not filtered crew. Fixed crew, I said. And we group by pod group. Oh. No such column fixed weights. Wait, what? Fixed crew. Oh, I guess just weights. Huh? Fixed crew. Oh. Wait, fixed weight, it's here. Maybe I misspelled it? Wait. Yeah, there we go. Okay. And step 4 is filter your grouped table to just groups where the total weight is more than 1,000. Okay. So we do select group grouped. No. Grouped crew. How does our grouped crew table look like? It would be nice to... Well, we actually have it here. So we have pod group and total weight. Oh yeah. Pod group. Filter your group table to just groups where the total weight is more than 1,000. Okay, so select pod group from group crew. Why is it formatting so weirdly? From grouped crew where total weight is greater than 1,000. Order by total weight descending, I think. No, we also need the weight. There we go. When you're done with all the steps, hit the Get Step Queries button below this box. Get Step Queries. Okay. So essentially... Oh, we can do this. We can like create new tables with filtered crew as select staff name. Oh. Okay, let's run this bad boy. Success! Table aliases using with as. I did not learn anything like that. Okay. That's it. You've got it. You reach forward to send the information to the teams, but just as you do, there's another shriek of metal. Everything shapes. The ship is hitting a rock on its way to the depths. There's a moment of silence, then the smallest sound of shifting, followed by a crashing from the far side of the room, getting rapidly closer as the debris tumbles. You feel the wind knocked out of you. Everything goes dark. Captain Paul, can you hear me? Sinclair's voice seems very far away. You try to breathe in, but something stops you. Could be metal, could be something broken. Sinclair, are you out? We should all be boarded into the pods, Captain. I've been trying to reach you. Should be boarded or are boarded, Sinclair. Is there anyone not in the pods? I can't check from here. I was about to do a round. Captain, you okay? I can check from here. Don't move. Well, the culmination of this story will continue tomorrow. As today, we're kinda out of time. Wait. How do I save? Can I save? Well, even if we can't, it's fine. Close this. Oh. Oh. No, it's fine. We got it from the beginning. Okay, well. We are donezo for today. I can finally get into unpacking my little packages, even though I should be going to make dinner. But hopefully, girlfriend will forgive. Hopefully.